Welcome to Yellowbrick Summit. We're thrilled you could join us today. I'm Jeff Spicer, Chief Marketing Officer of Yellowbrick, and we're coming to you today from San Jose, California. We have a lot of really exciting news that we're going to be sharing today. All of it supporting our mission of helping businesses get real-time or near real-time insights from their data. All of it, regardless of where it's created. When we talk to our customers, they tell us they want real-time insights, but they say it's a challenge. Interestingly, a lot of data warehouse vendors say the solution to that challenge is breaking down data silos. We think that's a little bit simplistic. Yellowbrick has identified the problem differently. First, let's look at the changing nature of data, where it comes from, and how it's used in the enterprise. There's an enormous evolution in where data is created, and industry analyst firm Gartner predicts that over the next 5 years, 90% of data will be created outside of traditional data centers by things like IoT devices and remote applications. And not just in industries like manufacturing, telco, and logistics, but also in insurance, financial services, and retail. Second, many organizations are thinking hard about the ideal location of their applications based on things like the location of their customers and clients, network latency, and geopolitical factors that impact governance, sovereignty, and gravity. Third, there's the rise of distributed clouds. Now, this is the idea that you can manage a diverse but interconnected set of resources like private data centers, public clouds, and edge networks as if they were a single logical cloud. Distributed cloud is the first cloud model that stipulates the physical location of certain cloud services. In the past, location has not been relevant to cloud computing definitions. But with edge networks, location is extremely important. These factors complicate the drive to real-time insights from your data. And Yellowbrick sees an approach which is a sort of decentralized approach, where businesses can analyze data as close to its generation point as possible. We call this data warehousing for distributed clouds. It's a much more flexible and pragmatic way to look at data warehousing in real-time analytics. At its core, it means instead of bringing data to the analytics, you bring the analytics to the data. Data warehousing for distributed cloud requires a few things. First, a nimble data warehouse that can be deployed anywhere, on a public cloud, a private cloud, a cloud stack at the network edge, or any combination. Second, that data warehouse environment must be controlled by a single pane of glass. And then third, it has to be built on the concept of price performance. So this data warehouse has to achieve unparalleled performance and also tell you in advance what you're paying for that performance across the entire environment. That data warehouse for distributed clouds, it's Yellowbrick, and it's what we'll be talking about today. However, we're going to start with a deep dive into performance. One of the primary reasons that businesses choose Yellowbrick is because of our unparalleled analytics performance on data sets of any size, big or small. Yellowbrick's speed at ad hoc queries, reports, data ingest at massive scale surpasses any other data warehouse. But we've never shared details on how we achieve that performance until today. Today, our CEO, Neil Carson, is going to share the secrets of Yellowbrick and how we've rethought and re-architected the way a data warehouse should work for today's modern cloud-savvy businesses. Neil will dive deep into the inner workings of the Yellowbrick Data Warehouse and explain how the database is able to achieve performance that no other cloud data warehouse can. He'll introduce you to a concept that is unique to Yellowbrick. It's something that we call adaptive cut-through architecture. It's the idea that not only can Yellowbrick run on any infrastructure, it can leverage analytics-specific optimizations found in that particular architecture. Does that sound compelling? We think so, and Neil will have details. Later in our lineup today is Yellowbrick CTO Mark Cusack. Mark will host a roundtable covering the topic of distributed clouds and how data warehouse and analytics ecosystems must evolve to support them. Then we welcome GigaOM analyst Andrew Brust. He'll talk about the new normal within analytics, and after that, we'll turn it over to our Vice President of Business Development, Alan Holmes. He'll lead a discussion on how enterprises are planning for distributed clouds and distributed cloud data warehousing. And finally today, we'll end with a series of technical deep dives into Yellowbrick. We'll share more details on Yellowbrick architecture, as well as steps for testing Yellowbrick and getting started with the data warehouse. It's a lot of information, so please stay with us. If you have any questions, please use the chat function on your browser. And with that, we'll get started. It is my pleasure to introduce the CEO of Yellowbrick, Neil Carson.
Thank you, Jeff. And thank you, everybody, for joining us today. We're going to be having a chat about data warehouse architecture. We're going to talk about some of the things that we've done in the Yellowbrick database that are really, really special to enable it to run best on the latest systems. In particular, we're going to talk about the need for speed in data warehousing, how to make data warehousing go faster, the need for real-time data, how to make your data warehouse deal with data sources that are up to the second and analyze events that are happening in real time without needing two separate systems to do that. And finally, we're going to talk a little bit about data warehousing in distributed clouds. Now, on to the first subject, the need for speed. We all know that SQL analytics is about moving and processing large amounts of data at the end of the day. This is different from storage systems and networking devices because all they do is they move data from A to B. They don't actually have to process that data and turn that data into information. We have to process the data as well, which is a much harder problem in computer architecture to solve. This has got far harder in the last few years because of the advancements that have happened in the underpinnings of the database, which are data storage, data networking, and data computation. So we're going to look at all of those areas, talk about what's changed and why it makes the problem difficult and how we've solved it. So when we talk about the network, for example, databases take in data from the network or from storage. Massive accelerations have happened in networks over the last decade that are forcing a re-architecture of the data path. A typical network has gone from offering 1 to 2 gigabytes a second of bandwidth back in 2010 to offering 10 to 20 gigabytes a second or sometimes more in 2020. That's because common networks have evolved from being 10 gigabit networks to 100, 200, or 400 gigabit networks, over a 10-fold improvement in throughput. At the same time, storage systems have gone from being around 2 gigabytes a second for a typical server connected to a bunch of hard drives through to offering over 24 gigabytes a second today. So all of these problems make it harder and harder to do line rate processing of data at these rates. So I wanted to put those numbers in perspective. Those data rates that we just talked about are the equivalent of 3 DVDs of data, 3 movies, moving into the processor from the network and moving into the processor from the storage every single second. That means 24 hours of compressed video every second for full-length DVDs. Now, parallel databases are multi-node systems that work in parallel. What that means is our database, to keep up, every single second has to be able to process a month's worth of compressed movies. This is a non-trivial problem to solve. There are enemies of this processing rate in the modern software stack. The friendly penguin, Linux, can't keep up with these processing rates. The operating system can't go that fast. The TCP/IP networking stack can't go that fast. The file system can't go that fast. And hypervisors certainly can't go that fast. Okay, so this picture shows what's going on. On the right-hand side is the database. This could be our database or anybody's database. Data comes into the database from the network or the storage. For data that comes in through the network, it has to traverse hundreds of thousands of lines of complex code in the networking stack. That data then has to get copied into user space for the database to be able to use it, which is very expensive. Data from storage traverses the block layer in the kernel, which is hundreds of thousands of lines of code, the file system, which is tens of thousands of lines of code, before it ends up in the database. So all of this introduces inefficiency in the processing stack. Things can't possibly keep up. So what we've done at Yellowbrick is we've developed a new architecture called our adaptive cut-through architecture that cuts through all of that code, quite literally. And it's adaptive because it sees what's there. What does the hardware instance I'm running on support? Whether that's in the cloud or on premises doesn't matter. It will check, do I have a high-speed network fabric or a regular network? What protocols do I support? Do I have instances with FPGAs I can make use of to run scan accelerators on? Do I have NVMe storage or just regular vanilla storage? Do I need to deal with non-uniform memory, which is an issue in modern processors? The database will then choose the most adaptive way to get data in through the network into itself in through storage into itself, bypassing as many layers as it possibly can. So this deals with how to move data into the database at line rates. The next question is, how do we process that data? This gets more complicated. Looking back again through that 10-year period, we see a typical CPU has grown in computational throughput from just 6 cores back in 2010 to 64 cores today, over a 10-fold improvement in throughput. But the number of memory channels we have available, which is about memory bandwidth, how fast can we crunch that data? Memory channels is around how fast can we do random accesses when we join data and aggregate data and sort data. That has only increased 2.5 times in the last decade. So there's a pretty big gap here at the end of the day. If we can shift around 40 gigabytes a second of data, and we compress data because we don't want data to waste space, decompress, that works out over 100 gigabytes a second that we have to move. But if our memory can only do 200 gigabytes a second, by the time we've put that data into the memory and moved it back out again, we still actually haven't processed anything. All we've done is move data around without processing it. So this represents a really complicated architecture problem to solve. The reality is, memory is the new disk. If we look at this table, it shows the speeds of different types of memory in the server. L1 cache is phenomenally fast. It can move data at 12 terabytes a second in aggregate across all of the cores. L2 cache, 6 terabytes a second. L3 cache, a little variable, but of the order of a couple of terabytes a second. Our main memory, only 200 gigabytes a second. So in order to go fast, the most important thing is we actually can't use main memory to do this data processing, to store the data or retrieve the data. It's actually worse than that, and it's a double penalty because working with things in main memory actually messes up the caches, which are the places where things run fast. So in order to make things run fast, we have to process data from cache, not main memory. That means writing code that works with kilobytes of data, not gigabytes of data, almost like going back and programming for a 16-bit computer. We have to write code that avoids main memory for all data movement and all data processing at all costs. We've done that at Yellowbrick as well, but that changes a number of underlying assumptions in the database. We're going to revisit some of them. These won't be common knowledge, but if you think about it in the context of what we've just said, they make perfect sense. An outdated assumption is that databases should cache data in a buffer cache in memory to avoid reading too much from disk. This no longer makes sense. The effective bandwidth of reading data from storage can be the same as from main memory, and for the reasons we talked about, we can't have data going in and out of main memory. An outdated assumption is that CPUs can copy memory far faster than they can move it from the storage or the network. That's also not the case. Moving data across the network with specialist network adapters can be less resource intensive than copying it to and from main memory now, as well as not messing up CPU's caches. An outdated assumption is that keeping more data in memory is the way to better performance. Not true. As we've talked about, our CPU can run 10 times faster if it's processing data from caches. The challenge, of course, is to keep things there, which touches on concurrency, scheduling, workload management, all sorts of other topics that we cover in our technical white papers. Another outdated assumption is that Linux provides great services for high-performance networking. That's not true. The built-in networking is now 20 times less efficient than doing creative alternatives you can read about in our white papers. Another assumption is that Linux provides excellent services for high-bandwidth storage. Also not true. Building in your own storage I/O stack and file systems can be 100 times more efficient than what Linux provides you now. Now the question is, given all of these outdated assumptions we've talked about, all of which we've addressed and fixed at Yellowbrick, what does that mean in reality? So we thought we'd actually share with you some numbers. These numbers come from one of our customers that recently did testing comparing Yellowbrick to a very well-known leading cloud-only data warehouse. You can see massive benefits in performance and price and the economics of data warehousing. Yellowbrick on 16 nodes can support 10 times the number of users for a given response time of the competitive database running on 32 nodes. Where we end up with at the end of the day is 1/5 of the cost per query for that user running on Yellowbrick to meet their goals and response times. It's a phenomenal improvement as a result of revisiting all of these outdated assumptions. Another thing the customer noticed as a result of this competitive testing was that Yellowbrick was able to get the most recent data into the hands of their users much, much, much faster. This customer deals with streaming data, tens to hundreds of thousands of transactions per second. Data recency is very, very important to them. As data flows in from Kafka, it gets merged in an incremental ELT process and presented to users for analytics. Yellowbrick was able to do this process in seconds rather than the minutes that the competitive database took. Why is this? We found this a repeating theme. There is a need for real-time data now, and traditionally databases haven't done real-time data and big data at the same time very, very well. We have manufacturing customers analyzing test data from production lines in factories where you care about what happens right now. We have payment processors and digital security customers reducing fraud that requires analytics to always be working with the most up-to-date data. Historically, you've had to deal with two classes of databases or systems to do this. You have databases that do real-time data well. They work on small data sets. They're typically row-oriented. They're often OLTP. They have high-speed transaction logs, or our customers have had to resort to buying specialist streaming SQL engines in the past. You've had databases that do big data well. They are column-oriented. They do bulk loads. But in trying to get them to work with more recent data, you'll hear phrases in the pitch from those vendors like talking about forcing you to do micro-batching and having to aggregate your data. Products that combine these two traits have generally been niche products, special purpose, not general, horizontal, trustworthy, high quality of service databases with workload management and high availability and fault tolerance and everything else. So why run two databases or two SQL engines when one will do the job? At Yellowbrick, we've solved this problem. Our storage engine internally has two data stores. We have a row store that scale up, optimized for commit latency, for real-time trickle inserts from SQL, data streaming in from Kafka, data streaming in through CDC from OLTP databases using tools like Golden Gate or HVR. That row store, when the data gets to a sufficient size, the data automatically gets moved to our column store, which is scale out, optimized for throughput, compresses data aggressively, auto-indexes, auto-sorts, clusters, supports partitioning, and is protected by erasure codes. Tons of cool technology there. These two stores are both unified with consistent ACID transaction semantics across both. They commit, they roll back just like you would expect. So at the end of the day, real-time data is immediately queryable alongside data at rest. You have one database, not two. You don't need SQL streaming engines. You don't need inflexible in-memory databases. You can have the economics of big data combined with real-time speed and streaming all in one data warehouse. But that data warehouse doesn't have to be centralized. Our friends at Gartner agree with us. They said over half of enterprise-generated data will be produced and processed outside traditional data centers or a centralized cloud by 2022, compared to just 10% today. By the year 2025, that number will climb as high as 90%. So today, a number of our customers deal with this. Our manufacturing customers deal with data made at the edge in factories. Our hospitality customers are dealing with data sovereignty concerns and regulations that means their data sets can't be exported beyond their territory. Our insurance customers are dealing with vehicles enabled with telematics. Our telco customers are dealing with the exponential data growth enabled by 5G networks. Our vision is to bring the analytics to the data rather than the data to the analytics. Analytics at the network edge, like in factories. Analytics software as a service in multiple public clouds. Analytic platform as a service in customers' private cloud VPCs. And of course, in on-premises data centers and colo facilities as well. So stay tuned for some really cool technology previews that we'll be putting out very, very soon, alongside today's announcement of Yellowbrick for distributed clouds. So to summarize, we've covered today the need for speed, the need for real-time data, and talked a little bit about data warehousing in distributed clouds. I wanted to just thank everybody for listening, including our brilliant customers. Thank you for coming today. I encourage everyone to stay tuned into our summit to hear even more exciting stuff.
Organizations of all kinds rely on data analytics to stay ahead of the competition, to run core business applications, or just to survive during unforeseen disruptions. But the current data analytics platforms are failing under the stress of new data volumes, application demands, data complexity, and more concurrent users. Meanwhile, data is becoming more distributed. For companies that need immediate access to data produced far away from headquarters, or that need to keep data on premises for compliance reasons, centralizing data in a single location isn't an option. For those reasons, the era of distributed clouds has begun. Enter Yellowbrick, the first data warehouse for distributed clouds. Yellowbrick combines the best price performance available from a data warehouse for immediate insights at a fraction of the cost of alternatives, with the freedom to deploy in private clouds, as a service across multiple public clouds, at the network edge, and all the above if needed. Plus, deployment, data integration, and management are so simple, you can be running meaningful analytics within hours. How did we do it? We reinvented analytics database architecture from the ground up to shatter limitations on performance and concurrency at scale. Now, companies can get faster, richer, more accurate insights from data wherever it's located, all while saving millions. Yellowbrick gives you the power to make faster and better decisions wherever they're needed, in the central office or at the edge. The ones that vault your business ahead of the competition now and in the future. Try a free test drive today.
Thanks and welcome back. We've been talking about distributed clouds in the enterprise, how they're an evolution of hybrid clouds and how they can solve some of the complexity that comes with hybrid clouds. Next, we're going to hear from our panel of experts who are focusing on the transformative capabilities of distributed clouds. We're joined by Salima Rice, the Chief Data and Analytics Officer for GRI, Srini Sankar, the Enterprise Data Leader for Hanover Insurance Group, and Matthias Baumhoff, the CTO of ThreatMetrics, which is part of LexisNexis Threat Solutions. This roundtable is led by Yellowbrick CTO, Mark Cusack. Mark, over to you.
Thanks, Jeff. Hello and welcome to the panel discussion at the Yellowbrick Virtual Summit. Joining me today are three outstanding industry experts in data and analytics. And over the next 20 minutes or so, I'm really looking forward to a lively discussion around some of the challenges and opportunities emerging within the data and analytics space today. Now, before I let each of the panelists introduce themselves, I'd like to quickly frame the discussion that we're going to have. Well, many businesses today are seeking to leverage the speed and agility that the public cloud offers to their data analytics needs. But in reality, what we found is around 60% of businesses are actually adopting a hybrid cloud stance, where some of their data and analytics remains on premises, in their private clouds, in their own data centers, and some of their workloads are transitioning to the public cloud. Now, unfortunately, hybrid cloud deployments can actually introduce further complexity into what can already be a complex analytical ecosystem, because now we have different hardware stacks and software stacks in different locations on premises and in the public clouds. So hybrid clouds can make the task of data management, data access, governance, security, and privacy a little bit more difficult because of the heterogeneous nature of the infrastructure involved. Now, as a result, new ecosystem patterns and deployment approaches are emerging to address some of the complexities that hybrid clouds introduce. Now, one of these new patterns is called distributed cloud. So today, we're going to be talking about distributed clouds and in particular, the role that data warehouses will play within this emerging architecture. So joining me to discuss the challenges and opportunities that distributed clouds will introduce are Salima Rice, Chief Data Officer at Geometric Results Incorporated, Srini Sankar, the Enterprise Data Leader at Hanover Insurance Group, and Matthias Baumhoff, Chief Technology Officer for ThreatMetrics at LexisNexis. Welcome everybody.
Hello.
So I'd like to start with you, Salima. Could you introduce yourself and introduce GRI and your role and responsibilities there?
Sure. I'm Salima Rice, and I am GRI's Chief Data and Analytics Officer. I have been with GRI for about 4 years now. GRI is the world's oldest and largest managed service provider for human capital management. We're owned by Bain Capital, and we have about 150 customers globally where we manage their extended workforce. So we have a very large data sources. We use a lot of data, external data, and I've been in the role of Chief Data Officer pretty much my whole career. So
Right.
I'm very happy to be here and to be on the panel with you guys.
And thanks for joining us. And clearly you're pushing the boundaries in HR analytics.
Yes.
Right. Fantastic. So Srini, you're an enterprise data leader at Hanover Insurance. Could you tell us a little bit about Hanover and your role in the business there?
Yeah, sure. I head the data and analytics, information management, information architecture for the Hanover Insurance. I've been in this role now 6 years. I came early 2015. So my role is also new to Hanover Insurance. Hanover Insurance is in the business of property and casualty insurance, personal, home auto. It's one of the oldest companies in America, and I believe it's one of the earliest NICE stock market exchange company. Probably when NICE started trading, I guess. So it's a small and mid-sized, middle market and specialty focused insurance business. We have three major business lines, like personal lines, commercial, and specialty. So my role is to support cross-functional across all the business units, like all the data analytics needs, tools, technologies, and Mark, as you teed up, right, like the governance. So that's been my number one priority for the past, now close to 3 years, ever since I kicked off an enterprise data governance program. So we'll be able to talk more on that topic as well.
Great. Looking forward to it, Srini. Thanks for joining us. And Matthias, you're actually a long-standing Yellowbrick customer. Please tell the audience about yourself and about ThreatMetrics.
I am actually a long-standing Yellowbrick customer, and I have been with a company called ThreatMetrics for more than 10 years. Started out in Australia as a startup and grew big through the years. We have been acquired 2018 with LexisNexis Risk Solutions, and now we are part of a bigger family. ThreatMetrics is an online transaction risk screening service, basically, and we have created over the years one of the largest contributory databases in our space, what we call Digital Identity Network, and which is a large database of more than 150 billion keys, modeling the behavior of people in the online world. And we are operating at around 6 billion transactions that we do each month, and therefore we need a database to drive all that. I'm overseeing as a CTO all the technical aspects of the solution. Of course, we have also the analytics part, but also all the backend infrastructure I'm responsible for. And I'm very happy to be on this panel and share my insights.
Fantastic, Matthias. Yes, and obviously I know a little bit about your use cases, and hopefully we get a little bit more insight into them as we go on through today. So I'm going to start with the first question for the panel. And so fingers on buzzers. No, I'm just kidding. It's not a competition. But so by 2023, it's been suggested that more than 50% of enterprise data is going to be generated outside of the data center, outside of the public cloud. And analysts also suggest that this figure is going to rise to around 90% of all data generated by 2025. So how will analytical ecosystems need to change to address the fact that data is going to be highly distributed in fashion? And what do you think are some of the challenges and opportunities that arise, especially when you think of some of the near real-time use cases that are emerging given this distributed data landscape? Selena, could you give us your sort of thoughts on that topic?
I think the biggest complexity is around the foundational stuff. So we learned from the generational curse of 2008, 2009 that having a foundation, having data quality, data governance, having the metadata, that layer that is truly the foundation of how we get to great analytics is very difficult when you start looking at some of that data that it doesn't really come from traditional sources. So I think that's one of the complexities. But I also think that there are opportunities that this type of architecture is going to bring to the table. I mean, and for my team, especially, we've kind of coined the phrase architecting the data for analytics. So there's a purpose that we might have data that is in multiple clouds based on where that data is located. that might be one thing, but not all of that data is needed for analytics. Example might be time card data. You might not need that for analytical purposes. So limiting the amount of data that you actually need for true analytics and putting that in a more distributed cloud has been a game changer for us. We've actually been able to deliver an analytics within our product offering at a speed that I've never seen before, right? I mean, in terms of being able to turn around product development with 2-week sprints and monthly releases, and the velocity that the program teams are able to do in this environment is just extraordinary. I mean, definitely something that coming up. What you and I talked about, some of the older legacy programs and the way that we architected data previously. We spent 85% of our time wrangling the data. So by having just the specific data, by having the data already wrangled, by having it truly architected so that the data scientists can come in and start their work specifically on the data that's needed to solve that business problem. For many years, we identified what our most critical data was based on reverse engineering a report. Now that paradigm has changed to our most critical data is really the data that we need to solve a problem. And so by architecting the data that way and storing the data that way, it's been very good for us.
No, that's really interesting. I think you bring up a really good point about that 85% of time spent on manipulating, moving, preparing data. And I think from what I also gather from your comments, leaving the data within and close to the subject matter experts, the consumers of the data, the people that understand it, makes it much easier, reduces the friction, and you get faster time to value. So that's a great insight.
Yep.
So Srini, obviously within your space, you've got probably a complex ecosystem of data with lots of different applications, whether it's claims processing, fraud analysis and detection. But what's your thoughts around how some of these challenges and complexities and opportunities might arise within this distributed data landscape?
Yeah, having someone like I have been in the building the data warehouse, like having experience like for 20 years with many large organizations before Hanover as well. Right, see, we started, right, like we said, like as you mentioned, Mark, right, like in terms of we have to now like pull all the data into one central data repository and then give that for all the businesses to do reporting and analysis, right? Like that's been the case. So we started doing that, and then like we said, like, hey, now it's not gonna work that way. Like you got to like beyond data warehouses, like you got to really give dependent and independent data marts for the businesses to look at only their domain data and do their analysis because of performance challenges that we've seen. Traditional relational database management systems are not meant for data warehousing applications. Then came the appliances like, oh, here you are like the supercomputer to manage data warehousing. So now in the last 5 years, we've started building data lake, right? Like, okay, data lake, which is another disparate architecture, right? Like, hey, it's not dimensionally modeled or properly modeled for reporting. It's like a lake for true data discovery and predictive type of analytics. So I myself have done that. I like the big data strategy that I brought in like way back in 2016, building the data lake. And we also started building siloed data lakes for the business, like very similar to the data mart aspect of it that we started doing with the data warehousing, right? Like, but now it's starting to converge, right? Like the lake house. Okay, so why build a separate data warehouse? Why build a separate data lake? Now can you build a lake house? So we are also at that inflection point now, but I'm now challenging that architecture as well, right? Like, do I need to build a lake house, or can I have a logical layer that can go to any disparate source systems, be it the warehouse or data lake, or as you mentioned, like we have a complex claim system, we have a policy management system, like we have a 60-year-old mainframe data source that is one of the critical data sources. Now, can I have a logical layer, a data access layer of sort that can go to all these and bring in the data, the raw format, which is well suited for most predictive analytics? Like, yeah, I can understand, like, you have to build a proper transformational model for operational reporting, financial reporting, but for other analytics. So I think that is where the opportunities lie.
And that's very much what I see talking to customers as well. That idea of leave the data where it lies, move the analytics to the data, and then think about data fabrics, data meshes.
Exactly.
And they are kind of components or services that you would layer over something like a distributed cloud. Matthias, could you tell us a little about your thoughts on this subject?
Of course, and I think that this is a super interesting topic, and essentially everybody who wants to offer a low latency service worldwide faces this problem, because you have data enter locally, and you need to make if you categorize decision and analytics, there's this this real-time use case and this near real-time use case, which is impossible that you can offer this service on the low latency if you have a central data set. That's just no way you can do that. So everybody who has created such systems already had to think about, how can I have distributed point of entries, have streaming analytics at there where the data enters the system, have my real-time decisions and the near real-time decisions and analytics right there in the distributed part, but I still need to run analytics on a global scale. And how can I bring that together? And then there's all these hard to solve use cases like replication, conflict resolution, and even like stuff like eventual consistency. What do I do if two pieces of my puzzle are modified at two different geographical dispersed regions at the same time? How can I bring that together? And I think people solve that use case with lots of different tools and trying to bring a lot of different technologies together. And the better we can have either data warehouse systems or analytical systems that can deal with this distributed data, we are in a better decision to make both kinds of decisions, that those near real-time decisions and our global analytical insights into data. And I think that's going to be a good challenge, but I agree that close to 90% of the data will have this problem in like a few years.
No, I couldn't agree more. And I think this is where we're getting really into the crux of distributed clouds and thinking about how we simplify this problem. I mean, it's obviously not a silver bullet, because as we all know, when you're generating and driving towards business outcomes, there's people, processes, organizational changes that come along with it as well. But if we just focus on the technology for the moment, I mean, distributed clouds are seen as a natural evolution of the hybrid cloud, where we take those common services in the public cloud and put those same stacks everywhere. So now you've got a homogeneous infrastructure, a single plane of control across all of these geographic locations. And so what role do you think these distributed clouds are going to play in helping to address this kind of decentralized nature of data generation? And Matthias, let's stick with you. I mean, what about the rise of distributed clouds, and what benefits do you think they're going to bring in helping to join these data silos together?
So you're completely right. Distributed cloud is a natural extension of like the cloud move in general, where we are in the same position also as a company to take advantage of all those advantages of the cloud, where the easy scaling and the flexibility of the cloud is really very attractive. However, you still have the demand of those distributed systems, and distributed cloud can then solve use cases like data regionalization. You operate in different countries with different requirements for data residency, and even how do you treat PII. And this is one thing where I think that's also a big topic and also which data can you share across regions and which data you can't share across regions. Sometimes you need to anonymize data, you need hash data to be able to share that. Sometimes you need to aggregate data, and distributed clouds can really bridge the gap here of being highly agile in this while still maintaining privacy regulations of each countries in which you operate in.
No, that makes a lot of sense. I agree. I mean, that data sovereignty problem is real, and I think that is one area that distributed cloud infrastructure could play a role in helping to support. So, Salima, again, what's kind of your take on how distributed clouds might impact the landscape?
I definitely agree with Matthias that when we talk about data that needs to live in the country of origin, I think that's a big part for us as well. I also see where we have a lot of organizations that have had systems in multiple countries where they want to kind of bring it all together, kind of almost a persona view of your analytics. So analytics that are built for a CIO of a global organization, that level needs to kind of look at a certain amount of data from every country, right? And in my particular world, we have vendor management systems, and we might have one vendor management system for one company, but we also might have as many as 10 or 11 vendor management systems, maybe one or two in each country that they do business. And so, we don't want to be in the business of moving data out of a country. So by, aggregating only the data that we need for analytics within the distributed clouds has allowed us to be able to provide that persona-based analytical models for them. There's also, when we look at supply and demand and being able to bring in, very anonymized market data about rates and about the market and the types of skills rather than looking at the location and the person, right? I mean, we don't need all of that PII data anymore in order to find out, where's the concentration of Python developers in the world. And, with remote working now, you can find anybody anywhere, right? If you are willing to do that. So by having the data architected this way, we're able to answer questions so much faster than we could previously.
Got it. Yeah, it makes a lot of sense. So you're already deriving business value out of distributed clouds and leveraging it clearly. So that's great to hear. Srini, what's your view on how distributed clouds might change things?
Sure, like as Salima and Matthias mentioned, right? Like I couldn't agree more, right? Like it's all how we bring analytics to the data, right? Like so as we talked earlier in terms of, right, like, hey, leave the data where it is, but bring the analytics to the data, like without worrying about now the power of cloud, the scalability, the high availability, like in a global setup for the distributed organization, it makes it all the more possible.
I think that's a really important point. So final question is actually getting more specifically around data warehouses, a subject very, very close to my heart, as you can imagine, because obviously they often hold some of the most valuable data in a company's data estate. And what should we think about data warehousing in a distributed cloud? Are there any new use cases? Do you think that data warehouses will be put to when we think of data being distributed in such a geographically and logically disparate sense? And so, Matthias, why don't you start us off?
Of course. Also very interesting topic also for me. And you're right, data is like very important, but it's one of for me, it's one of three pillars in a successful SaaS business. The other two would be analytics, where you can actually drive insight, and also a platform where you can actually onboard products that actually collect data, which is also quite interesting. What I can see is if you offer services that are very, very dedicated to customers, you can actually spin up instances dedicated with customer data from a bigger data set in a cloud instance. And if I would have a data warehouse solution that supports that, you can actually free up your data warehouse solution to do all the global tasks, while all the customer-specific tasks can be outsourced in their own instance that possibly run even in their region, in their country, and they can do their own analytics with the help of our analytics with a data warehouse solution that actually supports that. Means also dealing with the replication if new data arrives in the central location, that they will be also distributed in this cloud location, and all the benefits that a flexible data warehouse solution brings, so that we can actually drive more specific value of like customer-centric value about whatever we have collected with our system. I think that's a very interesting use case, and it would be very exciting if we can put that into reality.
That is a really nice idea. I like the idea of potentially kind of provisioning, parachuting a data warehouse into a particular geographic region, and you're almost using it as a way of data sharing and collaboration, or pushing your data closer to the customer, so reducing data latency, supporting data gravity requirements. So that makes a lot of sense. Srini, what is your thoughts on data warehousing specifically within this emerging distributed cloud space?
Data warehouses are not going away, right? Like, so if someone thinks, right, like, oh, you've had data warehouse for 15 years, 20 years, now time to retire that, like, I don't think so. Like, data warehouses are not going away. There will be use cases for the data warehouses, right? Very specifically to the operational and financial type of reporting and analysis. Like, I think that is where data warehouses play a major role. And that is where, like, you require lot of transformation, right? Like, so you have to model it in such a way that it's suited for those, in our case, right? Like, so insurance, like we have SOX compliance, we have each individual state regulatory compliance, and we have various financial controls and operational reporting. So that is where, like, the data warehouse plays a major role. Like, to Matthias's point, right? Like, so if we have to lift and shift it and, like, distribute it on the cloud, right? Like, that is a possibility, right? Like, if we're not going to, like, break it, like, but are we going to add more into the data warehouse? So, like, this is something that I've been thinking through, like, for a few years now, right? Like, so we all built data warehouse because 10 years, 15 years ago, like, that's the only way to consolidate all the data into a single warehouse and then open it up for reporting and analysis. But now there's no reason to do that, right? Like, you can leave the data where it is, and you will be able to do that distributed cloud and logical data access layer. But for those who have invested, right? Like, so if we have invested, like, for the last 15 years with the Hanover organization, even before my time, when the Hanover started building data warehouse, so, like, okay, are we going to, like, completely move off of that? Like, definitely not. Like, so we would like to leverage that, but the new use cases will be in such a way that anything specific to that finance operational type of reporting is what will belong in the data warehouse.
Right. So if I were to play that back, I mean, it sounds like in your strategy overall, when you talked about data lakes earlier, you're very much just focused on using data warehouses for the right task. And, data lakes have their own use cases. If you're using SQL, highly structured relational model data, probably a data warehouse is where it should be. I think we'd all agree with that. So, Salima, finally, what are your thoughts on? I mean, you sound to be quite far ahead in your journey towards distributed clouds. Anyway, I mean, what is data warehousing playing in your business?
It's funny, listening to everybody. I was thinking about how fortunate I am that 4 years ago when I joined, it was what do you want to do? Like, what do you want to build? How do you think the data should be architected? And because they didn't have anything that I can say that we could have used at the time. So coming from the days of Kimball and Inman, I thought, well, we're not going to build my grandfather's data warehouse, right? So we kind of took the approach that we've got a blank slate. Like, if we could do it over again, how would we make it different? And so we actually don't have one data warehouse anymore that is for everything. Primarily because in people analytics, which is at the core of what is the ultimate, top level for us, is that there's a lot of PII. So by not bringing the world together and having it in distributed clouds right now was the way to go originally. Just because, I'm a firm, I actually wear the scars from 2008 and the financial crisis. And so I was, we're not going to, someday GDPR is going to be here, and we don't want to go back and redo it. So we put the controls in place in the country of origin where the data is created. Now, there are some countries where we could combine, but I think that there's so much value in having data only that you need to be able to use for analytics, aggregated for analytics. And I think that the data that you need to store for storage, and having that, whether it's a lake house or a warehouse, it has its own place too, and that's okay. But being able to have kind of a hybrid area now where we can ingest any data from anywhere in any format. So whether it's structured or unstructured, we have the ability to do that.
And that's incredibly important, isn't it? I mean, you've been in a great position where you're able to build up that stack from a kind of almost a blank piece of paper and get it right and iterate over time. So that's great to hear. Well, we're coming towards the end of our time, so I just wanted to thank my panelists. I want to thank Salima, Srini, and Matthias for joining me today for what was a lively discussion and some great insights there. And thank you very much to all of the audience. And I hope you're enjoying the Yellowbrick Summit so far, and hope to see you soon. Bye-bye.
Thanks, everyone.
Thank you. Bye-bye.
Bye, guys.
Thank you, Mark. So we're going to continue the discussion on distributed architectures and their impact on data warehousing. Edge computing, hybrid cloud data warehouses, multi-cloud systems, data-intensive applications. These are what our next guest calls the new normal of analytics. Andrew Brust is GigaOm's Research Director for Data and Analytics and ZDNet's lead blogger for Big Data and Analytics. Andrew, it's my pleasure to welcome you to Yellowbrick Summit.
All right, thank you, Jeff. I am lead analyst at GigaOm for Data Infrastructure and Analytics, and I focus on that same space as a blogger for ZDNet. I've actually been doing database stuff since the mid-1980s and business intelligence and analytics stuff since the late 90s. That has given me ample time to see all kinds of cycles, some of which repeat in the tech world, and now is no different. So we're going to talk about some patterns that have emerged around the data warehouse, around the cloud, and how those two come together around cloud data warehouse and distributed architectures. It's really just kind of one talk here, but it does fall into some subsections. We're going to talk about what I call the analytics new normal, some patterns around cloud adoption, the cloud data warehouse specifically. We'll talk about what edge computing is and how that ties into data warehousing and cloud data warehousing. And we'll finish up with some discussion of the distributed cloud. So this analytics new normal, if there were one thing that typified it, it's the fact that data is all over the place now. We have more applications, we have more APIs. All of these things tend to act as data sources, which means that the number of these data sources is just mushrooming. Customers are also using multiple clouds and multiple systems and platforms. And of course, systems and platforms, those are kind of vague words, but we choose those intentionally. It could mean operating systems. It could mean cloud platforms. It could mean database platforms or analytics platforms. However you choose to define it, there is, in fact, a great multitude of them used by different customers. And even if neither of these things were true, with mergers and acquisitions happening in the industry all the time, even if the two organizations individually had a perfectly consistent stable of technologies, once they come together, then obviously there's complexity added. What this means is that data is becoming more distributed, not less, and it's becoming harder to manage. I promise we're going to end on a high note here, but it's important to kind of take an inventory of the things that are stacking up as challenges so that we know how to take these challenges on. And the biggest challenge here is that even though the data is all over the place, the analytics has to be comprehensive. So you need to draw this data together in order to get a real 360-degree view of your customers, of your page views, of your price changes, of your transactions, whatever metric you are following. It needs to take all the data into account. And that means this data that's scattered everywhere needs to be gathered. The trick is, and I'm stepping on my own punchline here a little bit, but I'm doing it on purpose. The trick is that gathering has to be done more logically than physically. Ultimately, it's a mixture, but the logical unification is going to be our key to salvation here. Now, the pandemic has had an effect on all of this as well. There has been obviously an increased shift to online commerce, for example, even in hyper-local kinds of interactions and transactions. Even if I'm ordering food from a restaurant across the street, I'm probably placing that order online and paying electronically now. So there's lots more data to track there. That has created a heightened awareness and sensitivity around the need to protect data, and it's made some data protection regulations around the world more acute. And that means that some data has to stay in the national boundaries where it was created. So even if we had a great way to pull all of our data together physically, we're actually not allowed to do that in certain cases. And so that's going to drive the need for us to have distributed architectures, because our data actually needs to stay kind of scattered in a physical sense. There's been a general acceleration of digital transformation because of the pandemic. That's been said so many times, it's almost a cliche, although it bears repetition. Data and analytics at this point has been mainstream because of the pandemic. Let's think about it, right? We're all looking at this thing and hoping for improvement. We're looking at the number of cases and hospitalizations. More recently, now we're looking at the number of vaccinations, who's been completely vaccinated, who's had at least a single dose. We're looking at data all the time. We're looking at data visualizations all the time. Flatten the curve is itself a reference to data visualization. So now the notion of analytics has become really a household notion. And when you take something from business and you move it into it becoming a household notion, then it doubles back to the business side and the demand gets at least twice as large. One more thing that's happened not in all industries, but in several, is that people have been working from home. And if we're working from home, then now we're used to the idea that the computing infrastructure is not going to be physically co-located with the team. So guess what? That's how the cloud works as well, which means we're all becoming acclimated to cloud computing, because even the corporate data center is in effect a cloud if none of us or very few of us are actually working in the corporate office. So the pandemic has been a real catalyst. Now, this brings about some things that we have to be aware of around speed and timing. There is latency that has come into things. As data becomes more physically dispersed, that means that bringing it together is going to introduce some delays. Networks can introduce their own latency as well. And again, with these data sovereignty laws, we're not even allowed to move some data, even if we had a way to do that with perfect efficiency. Analytics needs to be fast, though. So even though we have these delays, if the analytics isn't fast, we're in trouble. And that's not just about convenience, and that's not about people being impatient or picky. The whole thing about analytics is that you're not gonna drive one query. You're gonna run a query, look at the answer, and that's going to inspire you to run another and another subsequently, iteratively. That's how you get to insights, is if you keep stacking questions on top of each other. And if we don't have interactive speeds, we're not going to be able to get to those insights. So the data needs to feel like it's all in one place, even if there is physical separation. And guess what? This kind of creates a bit of a contradictory place. It feels like we're asking to do different things that are at odds. So it begs the question, what do we do? And it can create a certain amount of despair. But again, we're going to end on a high note here. So if you feel a little despair, recognize that, but also maintain some confidence that there are good answers that will get you past these quandaries. The main thing that we have to do is split with the past, where we have been looking at the siloing, the physical siloing of data as a defect, as a problem that we have to fix. I mean, it's a natural way to look at it, but we really have to embrace the idea that data wants to be scattered, right? Because data needs to be close to the operational application that creates it and that maintains it so that we can have operational performance. We're not at the behest of analytics going to centralize all our data and then make things operationally slow. We don't want that. So we need to stop fighting this. We need to go with the grain and accept it as a pattern that is only going to grow. And again, that means we're going to have to integrate the data logically and not physically without moving the data. Some of it will move, but we're never going to be able to move all of it and coalesce it all into a single repository. And that means we need to bring analytics to the data. It also means, though, that if our infrastructure is going to be distributed in order to accommodate these patterns in the way the data domiciles itself, that nonetheless, we're going to need a way to manage all that infrastructure in one place and have the kind of sense that it is all in one cohesive whole. So now let's talk about some trends on the cloud side. And really what we're talking about here are what kinds of organizations have been adopting the cloud. Now, as we move from the left to the right, you'll see we keep kind of going around the outside of large enterprises. So many startups were born in the cloud. They're easy. Small and medium businesses simply have less critical mass and less inertia to overcome. So a lot of them have moved to the cloud, especially because there are operational and cost efficiencies to be had from it. Within large organizations, individual business units may have moved to the cloud, especially because really individual business units often behave like small businesses. Customers with workload specific requirements where they need to spin up some infrastructure to take care of a kind of a temporary or an ephemeral workload, get their work done, and then take the infrastructure down again. That's going to be much more efficient in the cloud than it would be in the corporate data center. So that may have created a mandate for them to work in the cloud. But even though we're kind of going around the edge of this, at this point, because of many of the trends we've discussed, especially in terms of the pandemic, a growing number of enterprises and industries are now seeing the cloud, the public cloud, as quite a safe place to get their computing done and quite an acceptable place, especially as the cloud providers meet an increasing number of different certifications industry-wide for that safety. Also, pretty much anybody these days who's doing a data lake probably has that data lake in the cloud. Although the data lakes began on premises, the model, the elasticity and the cost models for cloud object storage really makes it so that the cloud is the optimal place to have a data lake. So that has also eliminated some hesitancy toward the cloud. And then if we're taking analytics new normal and the cloud together, we have to think about the cloud data warehouse. There's so many use cases for it. First of all, there are data marts, which are really kind of departmental data warehouses, if you think about it. Those work really well in the cloud. Going back to that data lake, well, you probably want your warehouse to see the data in your lake and have very ready optimal access to it. And so Lake Warehouse Federation is another catalyst for creating a cloud data warehouse. You may also have seasonal bursts in terms of how much analytics needs to be done. And so the cloud is a great place to be able to provision extra infrastructure for those seasonal bursts and then go ahead and spin it down. And that can work in a pure cloud scenario or in a hybrid scenario. Now, we've been talking about how we can't move all of the data, but some of it, the really, really important stuff, we may move. But there's more of that too. And the old way of moving that data, where we would extract it and then transform it in its shape and its metadata, and then load it into the destination data warehouse, that's not nearly so feasible as it used to be because of the volumes of the data. Now it makes more sense to extract the data, load it directly into the warehouse, and then go ahead and transform it once it's there. Cloud Data Warehouse is great for that because we can bring up additional clusters that are dedicated to the ELT, extract, load, and transform workloads. And then finally, if you want to have a close bond between your business intelligence, your data integration, and your data warehouse, the cloud is a great place to do it. So a cloud data warehouse may, and typically is, and increasingly is the best choice. Now, some trends in the cloud data warehouse world include some obvious ones, right? Customers are doing hybrid cloud, mixing their on-premises infrastructure with cloud infrastructure. Most customers these days, or a growing number at least, have business with multiple cloud providers, and it's container technology like Docker and Kubernetes that is making this possible, because it really takes all those different environments and it makes them look to the software mostly the same. That makes things much more agile. It makes software much more portable. In terms of my own research, well, with data warehouses, I'm only looking at them once a year, but there's a couple of interesting things there. The first time I looked at data warehouses, the title of the report was Revenge of the Data Warehouse, because it seemed like big data, a lot of the believers in big data thought warehouses were obsolete and that they were going to go away. First of all, that never happened. And second of all, the cloud changed the warehouse deployment models and cost models such that they can now take on the same volumes of data as technologies like Hadoop and Spark. So the warehouse never went away. And in fact, now it is a bona fide big data technology category of its own. And so it's come back with a vengeance, hence the name. But here's the thing, when I'm doing research around other things like business intelligence and all facets of data management, from data catalogs and data governance, all the way to data quality and master data management, all the vendors in those subcategories are looking very hard at making themselves compatible with cloud data warehouse platforms. So even when you're not looking at data warehouses, they're actually quite central, even when you're looking at other categories. We're also well past the initial days of cloud data warehousing. The first platform was Amazon's Redshift, and while that's still obviously a major player, it is not the dominant force that it was. It's got lots of competition. Speaking of competition, there's one vendor out there that was sort of the darling competitor for a while, and now even it has been around long enough where people are starting to look at it and look at their bills and are starting to get a little bit skeptical or pessimistic around that vendor, the way they did some of the old incumbent database vendors in the last couple of decades. And we talked about this one already, but it bears repetition. We need to bring analytics to the data. A couple of reasons for that. The more data you have on a given cloud, the less incentive you have to move it. It's complicated. It's also costly. There are fees for data egress, for moving data off of a cloud. So it makes much more sense in a data warehouse scenario to be able to have a multi-cloud strategy. And in addition to multiple clouds, what about this thing called the edge? So what is the edge? The edge is about doing computing in remote locations, whether that's branch offices or the factory floor, or in the agricultural world, even the fields where the crops are growing. And for data warehousing, edge is still kind of a future, but we need to be prepared for it because edge data warehousing is going to be a necessity soon enough. So invest in an architecture that will allow it. And here's the thing, we need to make sure that our data warehouse on the edge and in our data center and in the various clouds where we're working is the same platform. So we can have consistency of environment as we move from position to position. The needs that are going to drive data warehousing at the edge include the fact that it's going to make a lot more sense to process the data there and then transport only the summarized data to the central data warehouse. So we're going to want to aggregate and we're going to want to filter at the edge locally. And we don't just want a generic stripped down edge database for this, right? We're going to need to do real analytics there. And so we're going to need real data warehouse platforms to run at the edge. So again, this is not a super necessity today, but it will be very soon. And you need to plan for it as you make your platform decisions. That sort of begs this question of the distributed cloud. If you take multi-cloud and hybrid cloud and the notion of edge and data center together, and data center can mean corporate data center or cloud data center. And then you also consider that in each of these environments, you may have different infrastructure. You have more control over the infrastructure in your own data center. You're going to have very commoditized infrastructure in the public clouds. And then out at the edge, you're probably going to have specialized low power hardware that may be running on a different CPU platform than you would in other places. We're going to need approaches that accommodate all this. Just as we were talking about with data being dispersed and scattered, we need to embrace that as the pattern. It's a feature, it's not a bug. So there are allies that can help you here. And the allies in your distributed cloud journey, first of all, include distributed architectures and an embrace of data virtualization, not for all of your data, but a goodly amount of it, the connectivity to it will need to be virtualized rather than relying on this idea of physically importing all of your data into the central warehouse. You'll need a unified control plane, which means you need to be able to manage all of this infrastructure, even if it's physically distributed. You want to be able to manage it just as easily if it were all physically concentrated in the same facility. Container technology and container orchestration, again, like Docker and Kubernetes, that is what makes this so feasible, because as you move between environments, the differences between those environments can be abstracted away by the container platforms. And one last thing, it's really important as we consider the future to also consider the past. The past models for data warehousing involved appliance hardware form factors. And that introduced some problems, especially in terms of expandability. But one thing that was great about the appliances was that the hardware, the storage, and the networking were highly optimized. And in hybrid scenarios where we are going to have some of our infrastructure on premises, we need to look to optimized hardware to help us out here as well. And in general, think of new patterns, but don't reject what we used to have. Rather take a strategy of cherry picking what was best about it. And optimized hardware should not be written off. So that is most of the conversation. Let's just kind of summarize and maybe put a nice little capstone on some of the stuff that we've talked about. First of all, look, big data itself was not a fad. Big data is real. It's real. Even small businesses have big data. And if they don't now, they soon will. But ditching the data warehouse, or the very premise of ditching the data warehouse to handle big data, that was a false choice, right? We shouldn't get rid of the familiarity and the power of relational platforms and SQL querying unless we absolutely have to. And we absolutely don't have to. And the cloud plus the data warehouse has made that a clear fact. Data and infrastructure are scattered by design. Let's stop thinking about this as an exception to be addressed and resolved. This is actually the pattern. As I said before, it's a feature, not a bug. So don't try and fix it, because actually it's not broken. This is the way it was meant to be. Adopt a platform that can run anywhere, any cloud, any corporate data center, and eventually make sure it's in the roadmap for that platform to run at edge locations as well. Combine your optimized and commodity infrastructure, as both have their place. We're still going to be in a world where some of the infrastructure we're going to want to manage directly, and where we have the discretion to run optimized hardware, we need to consider doing that. In general, and this is our last point, don't jump to extremes. When a new technology category emerges, and again, I've had enough time to see a lot of them, the industry just loves to jump on a bandwagon, go all in on that new category, and kind of deprecate old patterns that have worked really well as obsolete. Some of them aren't obsolete. Some of them are just classic. And ultimately, you have to look for equilibrium, for a balance between the best of the old and some of the really innovative things of the new. And that really puts it all together. Very happy to be involved in this event. Thank you very much for your attention. And I'll say goodbye right now on behalf of GigaOM and Yellowbrick.
How are enterprises planning for distributed cloud? What are some of the factors impacting their decisions? And how should they start thinking about unlocking the value of their data that's been created in a distributed environment and doing it in a way that's cost effective? Joining us next for this conversation are Jay Chitnis, the VP of Global Alliances and Business Development with Protegrity, Nandakumar Sivaramnan, Practice Head of Data and Insights with MTech, and Vinay Mathur, the Chief Strategy Officer with Next Pathway. This roundtable is hosted by Yellowbrick's VP of Business Development, Alan Holmes. Alan, over to you.
Thanks, Jeff, and welcome everybody to the Partner Roundtable. I'm excited to announce today's panel. First, I'd like to introduce Nanda from MTech. Nanda, can you share a few words?
Okay, thanks, Alan. I'm Nanda. I head the data and insights practice within MTech. And for the last 5+ years, we are into the horizon of both hybrid, distributed, and all those things. And we are a wonderful partnership with Yellowbrick for the last 1.5 years. And we are looking forward for this one. Thanks, Alan.
Great. Hey, thanks, Nanda. Thanks for joining us from around the globe. Jay, over to you.
Hey, Alan, thanks. So I'm Jay Chitnis. I run our all the partnerships here at Protegrity. So for those of you who don't know, Protegrity is a data security and AI company, and we've been partnering with Yellowbrick on quite a few engagements, and I'm excited to be here. So Alan, thanks for having me.
Yeah, glad to have you. Thanks, Jay. Vinay, over to you.
Thanks, Alan. I'm Vinay Mathur. I'm the Chief Strategy Officer at Next Pathway. And all we do at Next Pathway is focus on automating migrations to cloud and hybrid cloud environments. So we partner very closely with the folks at Yellowbrick on making the customer journey from their legacy applications over to Yellowbrick a lot more seamless. Looking forward to the discussion.
Yeah, great. Hey, thanks, Vinay. Thanks for joining. So today's topics, I really want to explore what's going on with IT today and talk a little bit about the distributed cloud. Many folks have probably seen a number of sessions from Yellowbrick already. And after this, you'll see some technical content that I think you guys will find very, very interesting. But first, let me kick off with some recent survey results and get an idea on how enterprises are preparing for the post-COVID environment. So 84 respondents from our survey have increased or equal their pre-COVID IT budgets. So clearly, I think companies are starting to understand the value of IT and getting access to their data. 76% are investing more in analytics, and 51% still see security as a pain point. So guys, what are you hearing from customers, and what are their immediate priorities? So let me start with you, Nanda.
Absolutely. I think analytics is in the core piece of attraction, because we come across customers who is looking forward for lot of data within their ecosystem, but they don't know what to do with the data. That's where the data visibility comes into picture. So we strongly believe that, okay, those kind of customers who has been bringing the lot of importance of the data, the decision making is always behind how effectively they can actually represent the data to their stakeholders. It can be based on analytics, it can be based on artificial intelligence, cognitive services and all. And surely a combination of hybrid and cloud really play an important role there. That's what we see with our existing customers right now.
Excellent, excellent. Jay, over to you.
Yeah, it's interesting, Alan. So, we kind of play at this intersection of cloud with analytics, and then obviously I kind of mentioned security. So our belief is really that data is where the security layer needs to be. So what we do is we protect data, whether it's in motion, at rest, or in use. And so this notion of security being a pain point is kind of an interesting one, because we've always heard that, right? We've always heard that security is a pain point. But a lot of times, to what Nanda just said, it's really unlocking and unleashing the value of that data, so you can go and run some interesting new models, develop new ways of getting at revenue streams that you probably weren't able to do because you weren't able to leverage that data. And so what we're seeing is this triangulation of IT budgets kind of coming back, if you will, analytics investment, significant investment from the analytics side, and really heading it up on leveraging, not thinking of security as, God, I gotta do this, to how do I take that and being able to monetize that in some new way. That's what we're seeing. That's what we're hearing from customers.
No, fantastic. I think that makes a lot of sense, Jay. I think security always, it's about risk mitigation. So I think at that point, it's really an opportunity for Protegrity and Yellowbrick and frankly, others to really bring that to as a solution. So over to migration. So what's next pathway here? And migration has always been a pain point. So I'd love to get your view.
Yeah, thanks, Alan. No, absolutely. And when you talk about risk mitigation and Jay, when you talk about security, these are big questions that get asked right at the beginning from our customers. And so where we see customers asking questions in terms of what their current focus is and first priority is in a migration context is looking at an end-to-end solution. So what does that end-to-end roadmap from their legacy application over to hybrid cloud and cloud environments look like? And so the most important thing about that is risk mitigation. No one wants to start a migration project until they know exactly how they're going to approach a problem and make sure their business isn't impacted. So we take a holistic look at the entire journey, from planning to the actual workload migration and then over to cutover. And where we see right now a lot of customers asking a lot of questions is on that planning side. And so where do they start? What workloads are best suited for a cloud or hybrid cloud environment? And what's the low-hanging fruit in terms of where they can go and start and prioritize their efforts on? So that's where we see a lot of customers prioritizing, especially when you look at a distributed cloud architecture, which is quite exciting.
Yeah, no, that's a great point, Vinay. And that's a great lead-in, I think, as we kind of transition and start talking about distributed cloud. I want to share some survey results we have around the cloud. And this is, I don't think, a big surprise, but I think it just validates why we think distributed cloud is going to be an important strategic initiative for enterprises going forward. 86% respondents view hybrid cloud as critical to running their business. I think enterprises betting 100% on public cloud and moving data and not only the cost of doing that, but just the risk of moving really has either slowed down adoption and or is a strategic initiative that really warrants a lot of investigation. 63% are running multiple data warehouses. They've got not only data in potentially silos, and I know Nanda, you can talk to that, but just spread out across the company using different technologies. And we think there's a better way to solve that. And then finally, customers are starting to look at the edge as a deployment model. Whether they're currently in on-premises or private cloud or public cloud, moving to the edge is really creating an opportunity for putting analytics and data warehousing out where the data is being created. So when we think about hybrid cloud and the challenges, there's really managing multiple technologies, user experiences across private and public clouds. There's different identity and access management approaches that really impacts deployment and security. And provisioning resources is different, whether you're on premises or private and public, which means you got to have different types of capabilities, skills, and frankly, people to really manage that, what is becoming a very environment. At Yellowbrick, we have announced a different approach, and this is really the data warehouse built for the distributed cloud. And the whole point of that is not only giving our customers options on where they want to deploy, not only their data warehouse or where data is being created in analytics, it's providing a unified control plane that allows you to manage those resources in those different physical locations across the enterprise. So the goal is really simplification for data access, providing common security policies, minimizing data movement, and delivering a data warehouse anywhere and analytics everywhere. So guys, what's your take on distributed cloud, and do you have any use cases that come to mind? And I'll start with you, Vinay.
Yep, thanks, Alan. No, absolutely, and we see our customers asking for a similar architecture to distributed cloud all the time. And so in a migration context, we never see, even though industry tries to put this in our heads, and I hate this cliche of lift and shift, but you never see those types of migrations really taking shape. When a customer is moving off a legacy application over to a modern platform, hybrid platform like a Yellowbrick, they're often doing what we call a lift and fix. They want to optimize their application and their workload to best take advantage of the new architecture in Yellowbrick or modern target. So one use case we see a lot in financial services specifically is around data lakes. And so we see, and this is a real case, we see customers asking a lot of times, how can they create a logical architecture where they may have different physical instances of either an on-prem cluster and then a new environment, either in hybrid cloud or in a cloud environment, but how do they stitch it together? How do they link it such that it's centrally managed? Data might be in a couple of different places, but they want to manage analytics, they want to manage security, all centrally. So that's where we see a huge use case for it, and we're working on a couple of those cases right now.
I love that lift and fix moniker. I think that that really articulates well. So Jay, pick up on that theme. Where does security fit in, and how do you guys see distributed cloud providing an opportunity for Protegity?
Yeah, so I want to pick up on something that I think Vinay said that was interesting. It's this notion of being able to just quickly, easily move things. It's not a trivial matter. And oh, by the way, there is no such thing, at least from what we've seen, as any customer that says we are all in and only all in on public cloud or only all in on on-prem. It's not a question of are we going to do public, or it's not a question of if there's going to be some data that's going to maybe sit on-prem. The thing that most people are realizing, and by the way, roughly, I read a report that roughly an average customer has 2.8 clouds. So what does that tell me? What that tells us is that data mobility and data portability is really critical. And so one of the things that we believe is that when you secure the data, you shouldn't have to think about, well, wait a minute, did I use a specific tool to secure it on my on-prem, and is that different? Is the data now somehow not protected when I move it into a public cloud or into a hybrid format? Really think that data should be protected once, and then the protection scheme associated with that data should follow it. And that's what we really believe. That's what Protegity is all about.
No, that's great. Thanks, Jay. So with that, Nanda, I know you have a broader perspective, in the consulting world. Maybe share your views on distributed cloud, and I know you guys are pretty excited about it. So anxious to hear
Absolutely.
your words.
I think it's a very interesting one, right? Because I completely agree with Jay and Vinay. The reason is that if you ask the MTech portfolio, in a sense, that what we come across is the customers who have invested a lot in the last maybe decades. And none of the customer would like to actually bring some magic on the day one, right? Because they would like us to respect the investments and see that, okay, where it is going to, and see that, okay, here, how can they adapt to the latest technologies, whether it is cloud, AI, cognitive services, and all. That's the importance of hybrid cloud comes into picture, because we come across a lot of customers where they have been in the ecosystem of on-premises for more than 10 years. Now they have the humongous amount of data, whether it is ERP, whether it is CRM and all. Now there's an opportunity for them to understand, okay, hey, what significance data can bring back? It's like, okay, data visibility, so decision-making process, security, can they partner with other ecosystems, so the business benefits, profit analysis, a lot. From that perspective, I believe that hybrid data warehouse and hybrid cloud is extremely significant, because at least to be honest, maybe out of 10 customers, what we are coming back in the last 6 months, or maybe in the COVID situation exactly, is that maybe 8 customers already talking about the maturity of hybrid cloud. Okay, can we bring a data lake concept? But same time, when we bring that data lake, can we secure the data? Because that's where we're talking about. When we secure the data, can we effectively migrate the data from one ecosystem to the second ecosystem, so that it is a centralized portion and all. So that's what distributed cloud is, completely a different landscape for now as customers, because as Vinay and mentioned, the fintech is it seems like fintech is one of the real icing on the cake. The reason behind is that they are talking about data, they're talking about streams, they're talking about security, they're talking about diversified platforms with respect to fraud detection and all. So there is an opportunity for us to think through how can we help them, because we come across maybe 2 to 3 fintech customers in the last 1 year, where we brought in the data lake solution for them, leveraging multiple data practices, design patterns, and all those things. Some of the few examples is the data lineage. When we want to attain some kind of maturity with respect to data, first thing is that people are talking about, okay, how much secured my data is, because now my data is going to talk a lot of stories back to my customers. I don't want to say all the stories to all the customers in a single language. It should be defined for a specific customer. Can I secure my data? So then that's where the bringing more attention towards the security. What kind of security? Because we talk about the row level security, we talk about the data attribute level security, we talk about the infrastructure level security, or even talk about the migration security, right? When you migrate the data from one to this thing, okay, I need to make sure that is in a single cluster, or it is not beyond some packaging model. It is completely secure, so that I can have the better control of the data. So seems like distributed cloud is moving in a very fast-paced environment. But especially one thing that I would like to note here is that it's not simple ecosystem. It's a combination of multiple things. That's where we bring along the maturity of the data. Okay, can we store the data at the hot and cold data? Can we bring the meaning to the data by adding more flavors like artificial intelligence? For example, fintech, the fraud detection, the customer sentiments, the customer 360-degree program. For all this purpose, we need the entire data within the ecosystems. So we believe that the importance of data distribution is going fast and fast. And I'm pretty sure with the data gravity in mind, it will surely come into the next stage.
Yeah, no, I think that kind of, Nandit, I think that really not only highlights the opportunity, but I like to go back to what Vinay said around lift and fix. It does, going in and respecting the investment, starting to think about how you can modernize, how you can augment what's already in place, and start to bring those insights and really the governance around, not only from a security point of view, but from a data management point of view. So that's great, guys. I just want to kind of start to approach closing time here and really articulate that from a distributed cloud point of view, it really is a partner ecosystem. And collaboration, from my point of view, is really at the heart of this initiative that we're driving. And in the coming months, working with partners like Protegrity and MTech and Next Pathway and many, many others, it's really about starting to build reference architectures and thinking about end-to-end solutions and customer references that really understand and want to take this vision forward, because the technology is catching up. I think there's a lot more insight, a lot more understanding about the value of data, how analytics being placed where the data is being created, the whole data gravity message that is real. And our initiative is really about simplifying the data modernization. We want to increase the deployment models, right? We want to put it, private, public, at the edge. that's a critical piece of this, and stitching it all together by reducing, the security and the migration risks that are always top of mind, and ultimately providing a single pane of glass for resource management and security. I think that starts to really simplify the deployment model and should reduce the anxiety about making a modernization move, and really, I think, start to share and demonstrate the benefits, both from a business point of view and a simplification point of view. So guys, with that, any final comments that you have that you could share with the audience around distributed cloud and what you guys are thinking? Just kind of quick comments. What do you say? I'll throw it over to you, Nanda.
I would say that the unified data set modeling, that's what exactly. So as you mentioned, with the edge coming into picture, where we have an opportunity to actually talk about the data, and that's what exactly this partnership and with partners like Protective, which are actually getting into security with respect to the migration, and we MTech, we actually get into services. One underlying statement in is that if we can build a unified data set modeling across the entire data ecosystem, that will go a long way forward.
Yeah, great, thank you. Jay?
Yeah, I think, Alan, what you're touching on is something that's critical, right? And that in the sense of so I'll use the analogy, it takes a village, right? And it's not gonna be something that we can do independently, right? So it's going to take the visibility into understanding what data sits there. Where does it sit? Is it sensitive data? It's really understanding and then being able to, as I think Vinay was saying, the critical aspect is not necessarily the technology per se. It's about the people and the process implications. Yeah. And so really culling through that, but being able to do so in a confident manner where you're not compromising individuals' identities, right? And we want to do this in an ethical way. Our responsibility, I think the challenge for us is really all about enabling new things to line of business individuals, right? So usually where our IT departments and stuff, security groups, for example, are used to saying, no, you can't do that. Well, now I think this is kind of flipping it on its head, and we're saying you can do it. We can do it in an ethical manner. We can do it where we can share that data without compromising individuals' identity. We can do it by enabling new revenue streams for line of business individuals that they hadn't really even considered before. So I think it's got to be a holistic view, Alan. Just being able to not only get visibility into the data, protecting the data, making sure that data can be portable, and that the security associated with it follows it. And then you can go and optimize, right? So I appreciate the sort of view that you guys have, that Yellowbrick has around distributed cloud, but also bringing an ecosystem of partners to go and help enable that. I think that's going to be critical over the next few years.
Great, thank you so much, Jay and Vinay.
No, thanks, Alan. And listen, pulling off of what Jay said again, and I think what you started with, Alan, is that holistic mindset, I think, is the most important thing. And so if you're a customer that's looking at migrating to a distributed cloud type of architecture, look at the holistic environment you have. Look at your footprint. Don't look at anything in isolation. It's all going to fit together. So when you look at a migration context, understand how data is flowing into your application today. See what's actually needed to be migrated, and what can actually stay on the current ecosystem, to Nanda's point earlier. Look at your actual core warehouse. Look at the tables. Look at the data sets. Determine what data sets are best actually suited to move to a different architecture, like a Yellowbrick, for example, where you may have more advanced analytic use cases that need more higher performance. And then look at the security side as well. What's your security propagation strategy? How is your data going to be secure at rest and in transit? And then look at your downstream consumers. Look at your applications that are actually consuming data. Look at your BI tools, your analytics tools, and understand exactly what the impact may be to them and how you can give them the best user experience in terms of both performance, security, and access to that data. So that holistic mindset is extremely important when you're beginning to plan for a migration to that distributed cloud architecture.
Thanks, Vinay. Guys, fantastic. I really appreciate sharing your opinions and supporting us. Nanda, thank you for calling in from around the globe, and Jay and Vinay, always a pleasure to see you. Thanks for the audience for joining us and attending. And at this point, we're going to end the session. I'm going to send it back over to you, Jeff. Thanks.
If you have any remaining questions, please chat them now. And thanks very much for joining us at Yellowbrick Summit. And please stick with us. We have a series of technical deep dives into Yellowbrick architecture and Yellowbrick for distributed clouds, as well as some demos of Yellowbrick in action. Thanks very much, and we hope to see you soon.
Hello, everyone. My name is Mike McWhorter, and I'm an engineer with Yellowbrick Data. In this session, I'll be giving you a tour of our new user interface. We've simplified the process of loading data, writing and editing SQL, and managing all of your Yellowbrick databases. The new UI also gives you a consistent management experience across all of your data warehouse deployments, which makes it great for distributed cloud environments. If you'd like to try it for yourself, the best way to get started is with one of our new test drive instances. And let's dive right into the session. This session is called Getting Started with Yellowbrick. Our goal is to get your analytics environment up and running as quickly as possible. And the best way to get started with Yellowbrick is with one of our new test drive instances. To request a test drive instance, all you have to do is go to yellowbrick.com and click on the test drive button. We'll provide you with your own dedicated instance of Yellowbrick free of charge for 7 days. You can load up to 60 terabytes of data to run performance tests and test out all of your applications so you can get a feel for how the system works. One of the first things you'll notice about Yellowbrick is that it's fast, really fast. We have a unique software architecture that can plow through billions of records in milliseconds, and we can do it at a fraction of the price that other data warehouses charge. But it's not enough just to tell you that it's fast. We'd like to show you by letting you test drive a Yellowbrick instance so you can see it in action. The test drive instance that I'll be showing you today is built on top of Kubernetes. This one is running in AWS on Amazon EKS. We're going to be making this available to all of our test drive users in the next couple of weeks, and we're really excited about it because it includes a preview of our new redesigned user interface called Yellowbrick Manager. I'll go ahead and log in so you can see what it looks like. We designed the new user interface to be clean and simple so that it's intuitive to use. The menu bar on the left will allow you to navigate to the different tabs. Right now we're on the Home tab. This is where you'll find all of our documentation, instructional videos, and the latest updates about new features. It also has contact information for customer support. So if you'd like to speak to an engineer or have any questions at all about the product, you can find our contact information here. Next, we have the Instances tab. This is where you monitor the status of your various Yellowbrick instances. One of the great things about Yellowbrick is that you can deploy it anywhere. You can run it in the cloud or in a private data center, and the user experience will be the same no matter where it is. Yellowbrick Manager provides a single federated view of all of your Yellowbrick instances, regardless of where they're physically running or what type of instance you're using. Right now, we can see our test drive instance, but if you had multiple Yellowbrick instances, you would be able to view and manage all of them from this tab. You can also monitor the health of each database and view your resource utilization here. In the Databases tab, you can see the different databases, tables, and database objects in each instance. In the Query tab, you can submit queries manually, as well as execute DDL or DCL commands on your Yellowbrick instance. And finally, the Load tab will allow you to perform bulk uploads into your database. So if you'd like to load your own dataset to see how it performs on Yellowbrick, this is where you would do it. Let's take a closer look at these tabs so you can see how they work. I'll start with the Databases tab. From here, you can see the different databases and tables for each instance. Just choose your instance from the pull-down menu and select the database you'd like to see, and it will give you a list of tables. We're going to select the TPC-DS database. When you select the table, you can see the specific details like table statistics, the table definition, and the activity logs. At the top of the page, the tabs will allow you to browse through all the different database objects that you have defined, such as views, schemas, sequences, or stored procedures. The tabs for storage, locations, and formats are used to load data from external sources. We'll come back to those in a minute. One thing you'll notice that is conspicuously missing from this list of database objects are indexes. There are no indexes defined for any of these tables. This is a great feature of Yellowbrick. You never have to build indexes. That's because every column is indexed internally. You'll get fast lookups on every column, and you never have to waste time building indexes manually. Once you load your data, you can begin searching it right away. The query editor is one of the new features in Yellowbrick Manager. This is a browser-based SQL development environment, and it has support for things like statement auto-completion, result set viewing, and it even includes some visualization tools. This isn't meant to replace any of your BI tools, but it should serve your purposes more than well enough for running simple queries or exploring your data set. To use the Query tab, the first thing you need to do is open a connection by going to the pull-down menu and selecting the Yellowbrick instance you'd like to connect to. Once you connect, it populates the schema browser and shows you a list of available databases and schemas. The next step is to connect to a database. I'm going to connect to the TPC-DS database by selecting it from the pull-down menu. The TPC-DS dataset is included with the free 7-day test drive of Yellowbrick. It contains 1 terabyte of randomly generated sales records, and it's designed to simulate a decision support system for an online retailer. If you're not familiar with TPC-DS, it's a standard benchmark that's used to measure the performance of a data warehouse. It has tables full of customers, products, and purchase records, and comes with a set of standardized queries that you can run to measure performance. We encourage you to run some of the benchmark queries yourself to see how our performance compares to your existing data warehouse. We think you'll be pleasantly surprised. Now let's run a query. Yellowbrick uses the same query syntax as Postgres, so if you're already familiar with Postgres, you don't have to learn anything new. All of the standard SQL, DDL, and DCL commands look exactly the same. If you have any questions about the command syntax or which data types are supported, you can find links to the documentation on the Home tab. To submit a query, you can type it in the query editor and click the Run button, or you can load an external SQL file into the query editor by going to the File menu and clicking Open. I have a set of TPC-DS benchmark queries on my local machine, so I'll just go ahead and load one of those. And I'll click the Run button to execute the query. When the query completes, we can see the output in the results window. You can click on the column headers to sort the results by column. And notice how the results set has different tabs. This will allow you to view the resource utilization for each query and to examine the query execution plan. Here, you'll see a graphical representation of the different steps. The operations that require the greatest amount of system resources will be highlighted with a purple glow. And finally, in the Explore tab, we have a graphing utility, which will allow you to create some quick visualizations with your result set. TPC-DS is a great benchmark, but when you're test driving a new data warehouse, the only way to know how well your application will perform is to load your own data set. That way you can verify that your applications work, you can measure the performance, and you can compare the performance to your existing data warehouse. With other data warehouses, you would typically load data by doing bulk inserts. You can do that with Yellowbrick too, but we have a much faster option. Yellowbrick has a bulk load feature that will allow you to load data directly from Amazon S3 or any S3 compatible object store. The bulk loader is optimized for performance. It can load data at a rate of several million rows per second, and it's the tool that we recommend for loading large data sets. Let me walk you through a load so you can see how it works. This is my test data set. I've created a bucket in Amazon S3, and I've uploaded a data file to my bucket. It's a compressed CSV file, which contains about 50 million rows of NetFlow data in comma-separated format. In order to load these records, the first thing we need to do is create a table so that we have some place to store them. We'll do this by opening the Query tab and creating a new table. First, I'll select the instance and the database. I'm going to use the Yellowbrick trial database. We're going to call our table NetFlow, and this is the DDL statement that we'll use to create it. If you're importing this data from another data warehouse, be sure to check Yellowbrick's documentation for the list of supported data types. In some cases, you may need to modify your existing DDL to match the corresponding data types in Yellowbrick. Let's go ahead and run this command. And when I hit the refresh button, you can see the new table in the schema browser. Now that our table has been created, let's go to the Load tab to set up our S3 connection. First, we select an instance and a database. And then we'll click Manage External Resources to set up our S3 connection. The first thing we need to do is add a storage device. So I'm going to click on the Storage tab and click Add Storage. I'm going to give it a name. We'll call it My S3 Storage and select the public schema. The storage type is Amazon S3 or compatible. Remember that you don't have to use Amazon S3. S3 is a standard protocol for object storage, which means you can load data from any S3 compatible object store as long as it supports the S3 protocol. In the future, we'll be adding new options for different types of storage devices, but for right now, the only available option is S3. Next, we'll enter our endpoint. Since we're using Amazon S3, our endpoint is s3.amazonaws.com. I'm using the US East 1 region. And next, I'll enter the credentials for my object store. These are the access key and secret key that you would normally use to connect to your S3 bucket. And then we'll hit save. Now that we've defined a storage device, we'll go to the Locations tab and define a storage location. Click Add Location. Enter a name. I'm calling this My S3 Bucket. It goes in the public schema. Select the storage device we just created. And lastly, we'll enter the path. This is the name of your S3 bucket. And we'll hit save. Next, we need to add a format. This is where you tell Yellowbrick how to parse the files that you're uploading. For example, are they comma separated? Are they tab delimited? Is it just a binary dump from Postgres? You can define all of that here. We're going to call this NetFlow format. We'll use the public schema. My input file is just a standard CSV file, which is the default configuration for the loader. So I'm going to leave all these fields alone. And I'm going to unselect the Has Header checkbox because my input file does not have a header line. I'll save that and then return to my load screen. Now we can start loading data. I'll select the storage location I just created and click Next. Then I'll select the format of the input files. And finally, I'll select a table to load them into. When I press the load button, it immediately begins loading data. While the load is in progress, it shows us the metrics of how fast the load is running. We can see that it's loading data at well over 1 million rows per second. And now that our load is complete, we can see that it loaded 50 million records in about 30 seconds. If I go to the Databases tab, I can see that my table has been successfully loaded, and now I can start analyzing it. To do that, I'll connect Yellowbrick to a third-party application. Connecting your applications to the Yellowbrick Data Warehouse is easy. To the outside world, Yellowbrick looks just like a Postgres database, so any tool that can connect to Postgres can also connect to Yellowbrick. This means that all of your reporting and visualization tools will work straight out of the box without any special drivers or plugins. The first thing that we need to do is create a user for our application. Your current user account has administrative privileges, so we don't want to connect with that account. It's a good general practice to create a user with limited permissions so that we don't have to worry about accidentally modifying or deleting any rows when we're analyzing our data. To create a user, we need to open the Query tab and issue some DCL commands. We're going to create a user called YBUser, and we're going to give this user read-only access to the Yellowbrick trial database. To connect your application to Yellowbrick, you'll need 5 things. You'll need the host name of your instance, the port number, the username and password, and the name of the database you'd like to connect to. The host name and port number can be found on the Instances tab, and the database name can be found in the Databases tab. I'd like to analyze my dataset with Tableau, so let's open Tableau and set up a connection. In Tableau, you do this by adding a new data source. I'm choosing the Yellowbrick connector. Remember that Yellowbrick is Postgres compatible, so the Yellowbrick connector in Tableau is really just an alias to the Postgres connector. Next, I'll enter all of my connection information. I'll select the SSL checkbox to encrypt the connection and click Sign In. Now I'm connected to my Yellowbrick instance. Now I can load my NetFlow table and connect to all of my existing dashboards. This concludes our session on getting started with Yellowbrick. If you'd like to reserve your own test drive instance, just go to yellowbrick.com and click on the test drive button. And remember, if you have any questions, our engineers are standing by to help.
Hello, everyone, and welcome to the summit. I'm Christian Schroeder, Vice President of Systems Engineering for Yellowbrick. I lead a team of global systems engineers that work with our customers to solve some of the largest problems in data warehousing. In our talk today, I'll be covering the Yellowbrick Architecture 101 session, which explores technology concepts that separate Yellowbrick from the competition. Now let's jump right into the session. To get started, I wanted to talk a little bit about what Yellowbrick is. For those of you that aren't familiar with us, we've created a SQL database designed for data warehousing and ad hoc workloads. Yellowbrick is a massively parallel, or MPP database designed for processing SQL queries across many nodes in a cluster. Our differentiation is our real-time results on the most demanding workloads. We're designed to run efficiently against very large data sets, providing guaranteed response times. This is the same efficiency that allows Yellowbrick to provide real-time results, even with small edge-based deployments. Today, I'm going to talk about the origins of legacy data warehousing architectures and the challenges that come along with those. I'll talk a little bit about Yellowbrick innovations, the Yellowbrick architecture and how that applies to distributed cloud. We'll get into our replication capability. We'll also talk about how we approach security, and we'll get into a conclusion. But before I get started on any of that, one of the questions I usually get when I'm talking to a new customer is what makes Yellowbrick different? Why does the world need another data warehouse? And to answer that question, I usually find it useful to talk about what technology was available at the time when most of these data warehouses were written. About 15 years ago, or sometimes even further back than that, is when most data warehouses were written. And if you take a look at kind of the technology that was available at the time, you'll find that the most common way to store data in primary storage was on disk drives. Solid state was around, but wasn't really at any kind of usable scale. And traditional disk drives are kind of the equivalent of a record player spinning. And they only provided about 100 megabytes a second of bandwidth per device. The most common networking was 1 gigabyte networking, and top tier CPUs only had about 2 cores at the time. In DRAM, I think the largest module was somewhere around 2 gigabytes. And at this point in time, VMware had just IPO'd and there was no cloud. If you take these constraints into consideration at the time when people were designing data warehouse software and technology, you quickly come to a conclusion that you have to keep most of the hot data in memory to achieve reasonable performance. All that hot data has to live in a cache or your performance is going to suffer because you can't reach out to those slow disk drives. DBAs were required to create and manage large indexes to achieve any kind of decent lookup speed. And because of all these constraints, standard Linux operating systems and network stacks were really the performance bottleneck. So they were often used with minimal modification. Most software at that point in time was really written as a monolith because there wasn't really a concept of microservices or cloud architecture. And software would really only be run on bare metal configurations with limited options. It turns out that one of the most challenging feats in technology is building a reliable data warehouse, or really database in general. With the scope of features that need to be supported in data warehousing, creating a solution that's reliable, that provides the correct answers is a daunting task and in many cases takes years. Once a reliable code base is achieved over a long series of trials and customer implementations, companies usually upgrade that software to address any problems that come up, and that can take years to really get to a point where you reach stability. Once that happens, companies are really careful not to jeopardize that stability with any kind of massive changes. Up until recently, any code that was written for data warehouses was really written as a monolith. So in order to make any kind of real innovative changes to that software, you're kind of performing open heart surgery on a delicate patient. And this is why you see very often that many large companies and established data warehouses have a real problem with innovation. It tends to stagnate. Instead of really kind of innovating at a core level from the database perspective, they kind of build ecosystem solutions instead, which allow them to kind of connect over established interfaces. When cloud migrations kind of began at a large scale over the last few years, it kind of left traditional data warehousing companies and new cloud companies with a challenge. How do you move quickly to a new code base when it would take years? So most of those existing data warehousing companies ended up shoving those existing monoliths into containers to move them to the cloud. And it restricted what a lot of the cloud properties could do because they couldn't write their own. So many of those would go to kind of existing data warehousing companies and acquire them and then wrap those into their cloud software releases. But at the end of the day, these were just the same old code that was developed years ago, now repurposed for the cloud without any really foundational changes. Cloud migrations have been going full steam for years now, yet 80% of the data warehouse spend is still on premises. While the percentage of spend on data warehousing is changing, it's slow compared to the rest of the industry. So why is that? The huge data gravity associated with data warehousing makes cloud migrations difficult. And while housing data in the cloud is relatively cheap, the processing horsepower and networking requirements to support thousands of users against terabytes or even petabytes of data becomes very expensive and very challenging. One of the biggest challenges of moving data warehousing into the cloud is that the most credible solutions from cloud vendors not only fail to scale linearly to address the largest data challenges, and that's talking in the hundreds and terabytes up to petabytes, they don't offer a simple way to move back on premises if you run into a scaling challenge a month or even a year from now. So if you spend the time to migrate your data into a cloud data warehouse and you have to change your mind based on cost, and cost is very hard to predict in many of these cases, you'll have a real challenge on your hands. Getting the data back means you pay big money on fees to get your data back out of the cloud. And to mitigate this risk, you really have to maintain two code bases. One, which is your old EDW on premises, and then figure out the ETL to this new cloud solution and maintain them both, and ultimately multiple sets of interfaces and applications. Some cloud vendors offer a multi-cloud approach, but don't kind of account for the on-prem requirements at all. Furthermore, with new technologies like 5G, more and more data is being processed at the edge. As the number of network edge devices grow, so does the amount of data generated far away from centralized public clouds and even data centers. In some cases, the networks that reach out to the edge are limited in bandwidth, and the amount of data generated at the edge outstrips the ability to send it home. We're finding that more and more customers need a solution that can analyze data at the edge, allowing them to query it remotely. This would allow them to kind of refine the data out at the edge and only send home what's needed. But running solutions in a container, and I mean a real C container, not a Kubernetes container, has its limitations. Power, space, and cooling are at a premium. But most on-premises EDWs or traditional deployments can't handle multiple terabytes of data without taking up tons of floor space and too much power and too cooling to tackle this problem. But what if a data warehouse was so efficient it could easily process tens or even hundreds of terabytes of data at the edge with a minimal footprint? If you think about that kind of resource efficiency, it could also be applied to saving you money in the cloud by not using as many resources per query. That efficiency could also drive new levels of performance so that you could solve problems that you couldn't solve before. Yellowbrick's core architecture enables us to provide real-time analytics regardless of deployment model. We've created a new data warehouse designed for the latest software and hardware advancements. Our data warehouse is new down to its core foundation. We've shifted the way that core elements of computing interact. We've removed the largest bottlenecks from the CPU. We've removed capacity limitations for memory, and we've introduced a new level of processor efficiency. We have a completely new optimized data path, which I'll get into in the next few slides. And we've also created an adaptive kernel that adapts to its environment and utilizes different optimizations based on what's available. If you remember back to the assumptions we talked about at the beginning of the presentation, the most common type of storage when most data warehouses were written was hard drives. The only way to make hard drives perform is to put very large blocks on them to avoid head seeks. Once the data is stored in hard drives, you're able to read the data into the buffer cache in DRAM, and then the processor can utilize it. One of the things you'll notice is that the pipe between the hard drives and the actual pipe on the memory bus itself were drastically different. The performance of memory in these traditional architectures was much, much faster. And this is why you had to keep most of your data in the buffer cache to obtain any kind of performance. This worked okay for the period of time when these things were written. Now we fast forward into the future a bit, and we find that SSDs are actually very common. And now one of the things you'll notice is that the pipe between this primary storage and solid state disks and the pipe and the DRAM bus are about the same from a bandwidth perspective, not necessarily latency, but certainly bandwidth, which is what you care about in data warehousing. If your software was written for the old paradigm, this is what happens. You end up storing the data in those large blocks on the SSDs, which isn't necessarily advantageous for that flash media. Then the data is loaded into the buffer cache. And you'll notice now that we're streaming data at almost the same rate across both buses into that same buffer cache. And there's so much data now flowing into that buffer cache that there's contention when the processor needs to access memory to process data for something like an aggregate or a sort. Also, the streaming of data through the processor into memory bros out any kind of processor caches, which drastically decreases the efficiency of the processor itself. Yellowbrick addresses this problem by exploiting a new data path that wasn't available until recently, giving us a direct I/O path from NVMe storage to the processor without using main memory. We store the data in block sizes that are most advantageous to flash memory, helping in both performance and longevity of that flash. And something new to our Andromeda hardware is our FPGA accelerator called Kaleida. Kaleida assists in the compression and filtering of data. That means that the only data that's passed to the CPU has already been filtered and is pertinent to the query. It also means that the data has already been decompressed by the FPGA, thus offloading many CPU cycles. You'll notice now that we're loading data directly into the processor caches and not into a buffer cache. This is one of Yellowbrick's key advantages. There is no buffer cache or caching of data anywhere in the system. We've optimized the data path so there's no worry of hydrating caches to ensure a cache hit. All queries perform as if the data is in cache all the time. Another advantage of utilizing flash this way is the density. Flash memory is 10x more dense than DRAM, so we can keep data sets on a medium that's the same bandwidth as memory and 10 times the density. So at this point, if you would run a query, all data would have been processed from flash and not used main memory. We've reserved main memory for things like sorts and aggregates, and it also leaves a totally unfettered memory bus for optimal CPU performance and efficiency. This allows us to give you a system that requires less DRAM and, as I said before, requires no buffer cache. While the data path optimizations we just talked about are key, Yellowbrick innovations don't stop there and are pervasive throughout the solution. We've utilized software approaches from the fields of high-performance computing and high-frequency trading and implemented them to provide the most efficient data warehouse that's ever been built. We've innovated from the ground up, starting with memory management optimizations and custom threading model in the kernel. These reduce context switching and manage CPU caches to maintain their data until tasks are completed. We have custom device drivers for storage and network that offer massive reductions in the amount of code per I/O and increase networking efficiency by over 20x. And as I mentioned on the previous slide, the custom FPGA hardware accelerators that bring massive deterministic performance improvements that can't be obtained with the standard CPU approach. This means that Yellowbrick will run efficiently at the edge on smaller configurations and use less resources in the cloud to provide unrivaled performance on the largest data sets or on our hardware optimized instances. Some of our optimizations exploit capabilities in modern hardware like NVMe or InfiniBand networking by implementing custom drivers. If you look at different deployments, you'll have a wide variety of infrastructure with a wide variety of capabilities. Will it be a 5-year-old laptop, Amazon EKS, a Yellowbrick hardware optimized instance? Because of this wide variety, Yellowbrick software must make decisions about what is optimal in that configuration or what software should be used in each case. The 5-year-old laptop probably doesn't have NVMe or InfiniBand, whereas our hardware optimized instance does. Our software adapts to every environment to utilize the optimal configuration. The core improvements like memory and thread management are consistent across these deployments. And to show you the efficiency, one of our engineers actually ran our Kubernetes-based deployment on a 5-year-old MacBook. Even with this very minimal hardware implementation, he was able to stream in a workload of 112,000 rows a second. Across all these deployments, you get the same consistent manageability, security, and unrivaled performance. Now I'm going to talk about our software architecture. One of the key things to think about is what do most customers want out of a data warehouse? They want complex queries against large data sets, and they want low latency inserts for streaming workloads. The problem is these two workloads are diametrically opposed from an architectural perspective. The scale-up row stores have historically been proven to handle those low latency commits for real-time inserts, while column-oriented stores have been more often used for their advantages with column separation and compression to optimize for large analytic queries. With Yellowbrick, data is actively managed in a hybrid row and column store that's been optimized for flash memory, as we talked about in the earlier discussion. That front-end row store minimizes the commit latency for real-time inserts, while the column store is designed to handle the massive analytic workloads, giving you the best of both worlds. Streaming inserts live in our row store temporarily and are automatically flushed to the back-end store based on time or volume without any kind of DBA interaction. The front-end row store is responsible for a bunch of functions, but in the interest of time, I just want to cover a couple more key points. And the first one is our Postgres connectivity. Our front end is based on Postgres because Postgres is one of the most widely used databases in the world and offers a compatible and common SQL dialect. This means that most analytic tools in the world already have a Postgres connector, which by the transitive property means Yellowbrick works with almost any analytic tool in the world. We also have our own custom tools like our bulk loader, which is capable of loading 20 million rows a second plus and moving data at line rate, which we also integrate with our partners into ETL tools to optimize for data movement. Also in our front end, you'll see that we have our query planner, query compiler, and they build parallel query plans that optimize the use of storage, network, and compute resources for all queries. The query plans are built with data locality in mind and minimize data movement across their network fabric. Another key point I'd like to cover is our workload management, which we'll get into more detail of in our advanced topics session. But our workload manager is a key feature because it allows DBAs to control resource allocation and as a result, quality of service for queries. Workload management divides the system up into resources or pools we often call lanes that are where kind of the queries are defined to run in. This means that no single query can dominate the system resources. DBAs can also define rules based on many factors, including users, applications, SQL, and define whether to prioritize or deprioritize queries. In addition, limits can be set for memory utilization or rows, so you don't have to worry about a new data scientist or analyst trying to return 1 billion rows to their desktop client. Kind of moving on to our backend column store, Yellowbrick is an MPP database, which offers linear scalability on that backend column store. Our column store has all the optimizations that we discussed earlier in the presentation around memory and thread management on the YBOS kernel. And our storage engine is a scale-out service that implements the distributed column store. And this is where that flash-optimized file system and erasure encoding scheme live. This is not only offers kind of peak efficiency, but also ensures maximum availability. Our storage engine ensures that even if multiple nodes in the cluster are lost, the system's still available. Our execution engine lives on top of that storage engine and is also a scale-out service that executes SQL query plans. And they run the SQL compiled code from the query compiler in a massively parallel function. Unlike many monolithic data warehousing software stacks of yesteryear, Yellowbrick's architecture is comprised of services that can be scaled out and adapted to meet the needs of the largest challenges and deployed in almost any environment. So what does all this architecture and innovation really mean? I wanted to show you what our value looks like to some of our customers, and this is just a small subset of them. It's not enough to perform well. You have to be consistent. You have to be reliable over time. You have to work well in a technology ecosystem and adapt to changing demands. Some of our customers have the most demanding workloads in their industries, and this is the business value of Yellowbrick, not only processing queries in record times, but the translation of that agility into solving problems that couldn't be solved before. Now that you have an idea about our architecture and the benefits of Yellowbrick, let's talk about deployments. Remember the earlier discussion where we laid out the challenges of moving into the cloud and the potential pitfalls of being locked in, as well as the challenges of trying to process data at the edge with minimal resources. Yellowbrick is now offering total flexibility and freedom. In private clouds, we can provide our own hardware-optimized instances on Andromeda that have unrivaled performance and density, offering over 6 petabytes of flash-based storage, as well as 2,500 physical cores and about a half rack of gear that can support almost any data warehouse workload imaginable. If you already have your own private cloud up and running, we have you covered with our cloud-native Kubernetes-based solution that offers all the same features and functions on your own private cloud hardware stack. In the public cloud, we offer a fully managed service based on our optimized instances, and this is a fully managed solution you can access via private link that offers flexible services around backups as well as replication for disaster recovery. These are dedicated Andromeda-based instances that offer the highest performance available in the public cloud today. And if you'd rather manage it yourself in your own VPC, we offer our cloud-native solution, just like in our private cloud, to be run on cloud Kubernetes stacks like EKS. At the edge, Yellowbrick's unrivaled efficiency really shines. And we've had customers request to run Yellowbrick on things like laptops, 1U servers, and other specialized hardware. We can also offer Andromeda 3-node configurations supporting up to 145 terabytes of structured data with minimal power and cooling requirements. And to make distributed cloud a reality, we've announced the Yellowbrick Manager that provides a single pane of glass to manage instances across the spectrum from edge to public clouds to in your data center, all from a single pane of glass. When talking to customers, most are comfortable with application migrations to the cloud, but one of the larger challenges is the migration of the data itself. Yellowbrick can create a common data layer across all deployments using our built-in replication solution. Replication is included in all Yellowbrick deployments and can be easily configured within a few seconds just using a few commands. Replication is per database and allows you to replicate data where it's needed for DR or locality purposes. Replicated data is compressed and frequency of replication is flexible to allow our replication to operate within a wide range of network speeds and latencies. The best part for our customers is that unlike most other vendors, Yellowbrick doesn't charge extra for replication and doesn't require any additional licensing or software. So if you have Yellowbrick, you have replication, configure it, use it as much as you like. And lastly, let's touch on security. When implementing a data warehousing solution across public, private clouds, and at the edge, you want to ensure that you have a consistent security posture across all deployment. Yellowbrick offers layered and pervasive security controls throughout the stack. Our hardware-optimized instances offer AES 256 self-encrypting drives for encryption at rest. And in our cloud-native deployments, we offer that same AES 256, but it's based on software and at the column level. All encryption keys are managed by our Key Vault, and we provide role-based access control with fine-grained object grants. We integrate easily with LDAP, Active Directory, and OAuth, and all external connections are encrypted with SSL TLS, whether it's our web-based interfaces, ODBC, or our own custom toolsets. Yellowbrick has designed the optimal solution for distributed clouds. Our unparalleled resource efficiency allows our customers to solve problems that were previously impossible to solve. It allows for real-time analytics at the edge where resources are limited, and our uniform infrastructure, unified control plane, and pervasive security allow you to deploy solutions where they're needed.
Hello, I'm Joey Foley, Senior Sales Engineer at Yellowbrick. Today we're going to be talking about Yellowbrick's architecture, our 102 course, Advanced Features. Let's jump into the slides. And today we will cover some of our most advanced features in Yellowbrick. Now, all of these features are native to the product and help enable the Yellowbrick distributed cloud experience. Whether you deploy in a public or private cloud, on-premise, or even at the edge, the features and the user experience are exactly the same across any deployment. The topics I chose for this discussion are advanced security, advanced workload management, and database replication. Each of these features allow our customers to use and interact with their data in new ways and enable the Yellowbrick distributed cloud architecture. So let's explore these topics in more detail. First, advanced security. When we think of security in Yellowbrick, we think of layered and pervasive security. Now, you may have seen this slide in other presentations, and it's a great overview of all the security topics. At Yellowbrick, security is important, and security is very important to our enterprise customers. We secure the physical hardware, and security is built into all of the software and connections. We have SSL and TLS for all external connections, whether it's loading data with our wire speed application YB-Load or running BI reports. It's always secure to interact with your data with Yellowbrick. We have unique ways of protecting data in ways no one else is doing in the market. And we are able to meet the stringent security requirements of our customers in healthcare, financial services, and insurance technology sectors. So let's double click on a few of these topics. HashiCorp Vault is how we protect data at rest. We create a secure key store, and customers can have multiple keys protecting a database, so no single person can possibly unlock it. Keys can be rotated. As with all things in Yellowbrick, it's simple to use and integrate. In fact, it's 2 simple commands: key store setup, encryption enable, and you have secured the physical medium. Next, it's about securing user access in Yellowbrick. We use role-based access controls. In Yellowbrick, everything in the database is an object, so granting or revoking privileges is easy. You grant or revoke to roles and provide users access to those roles. Role-based access controls can be thought of like this: access, what can the person see? Operations, what can the person read? What can the person write? Can the person create or delete files? And then sessions, how long can the person stay in the system? When will the login work? When will the login expire? As I mentioned, everything in Yellowbrick is an object. So I'm able to grant on a database, a schema, specific columns in a table. One thing that's really different in Yellowbrick is the ability to grant and revoke on encryption keys. But I'll talk more about that in a minute. We also secure the network access. So as I mentioned, SSL and TLS encryption for all clients, whether that's to our system management console, the SMC, or the Yellowbrick Manager, our client tools like YB SQL and YB Load, and passwords, they're all protected. Using SSL and TLS ensures that your connection between your client applications and Yellowbrick is secure, and we verify that the server is who it claims to be. Yellowbrick always recommends using a certificate from a trusted certificate authority. Here's one of the interesting things that I mentioned earlier: securing data with care, or column at rest encryption. Yellowbrick offers 2 ways to secure sensitive data beyond encrypting just the hardware. You can use functions like encrypt KS or decrypt KS to secure data, whether you're reading it through views or extracting data. These functions affect data post-write or on-read activities. But what if I wanted to secure data pre-write? Yellowbrick offers the ability to add encryption to the actual table definition in the DDL. You can then grant access to not only the table, but then the keys. And users that have access to those keys, they can actually see the data unencrypted. Data users that don't have access to the key or are not granted that key, they will not see the unencrypted data. So what's interesting about this is you can use multiple keys to secure different columns and different tables. And rather than having to build secure views or do things like that, it's just the grant and revoke of the keys that open up the possibilities for who can see what data. With advanced security features like CARE, Yellowbrick makes securing your data easy. Next topic we want to discuss is our workload management. And I believe we have one of the most advanced workload managements in the marketplace. So workload management, what is it and why do I need it? Well, workload management is about a couple different things. It's about balancing the resources in the environment to be able to apply priority to specific workloads. And it's also about the efficiency of the system, making sure that we guarantee all the resources are used and applied in the correct manner. Workload management is hard, and most vendors, they either don't offer it or it doesn't work well. In Yellowbrick, we're proud of the fact that we offer world-class workload management, because what it means to you is better efficiency of the resources that you're using. Rather than paying for elasticity or needing to spin up more compute, we make the system do more with less. So workload management in Yellowbrick is made up of pools and lanes and rules. Your workload management profile can have multiple pools. Pools can be assigned to, say, a line of business or specific activities like data loading or maybe short query bias. The pools are comprised of lanes, or how many concurrent things can run. They have a set number of lanes where each lane is reserved a set percentage of the pool, or we have a concept of flex pools, which you have a variable number of lanes depending on how it's configured. With flex pools, you can have a single lane with all the resources defined to the pool, or during turns of higher concurrency, the pool automatically balances the resources across multiple queries. And then finally, rules. Rules are what place certain workloads in the pools. Rules can be configured with a wizard or with JavaScript and give you the ability to affect queries in many different ways. So let's take a closer look at rules. So rules make workload management happen. Rules are comprised of three things: types of rules, conditions to look for, and the action to take if the condition's met. When the rule is applied determines its type. So we can affect SQL when it's submitted to the system, or while it's being compiled, if there was an issue and the query restarted, or even if it finished. And we can even apply conditions to running queries. Next is conditions. Conditions are what we're looking for, whether that's like a long-running query or queries running at a certain time by a certain user in a certain database from a certain IP address. We can look for any of these activities as conditions. Conditions can be set on query tags or on resources being used by a query, like how much memory is needed for a query to run or how many rows will the query return. You have a lot of flexibility and can combine any number of conditions to fine-tune what you're looking for. And next is the action that we take when the condition's met, whether that's prevent certain users from running queries at a certain time, or not letting a query that has like a select star without a where clause or a limit run. It can even be rerunning a failed query and giving it more resources so it can complete. We can move running queries to other pools if they're taking too long to complete, so things don't get stacked up behind those longer running queries or queries that need a little bit more resources. And Yellowbrick has over 75 different actions that can be applied at any time a query is running. So when we put all of these things together with workload management, it looks like this. Here we can see a profile that has multiple different pools with varying number of lanes. That top pool is for CEO activities, so we can guarantee resources for when those certain types of workloads come in. We have dedicated lanes for, say, larger running queries like data science activities, dedicated lanes for loads, things like that, and then a short query bias. And when we look at all of these little dots, each one of those is a query that's been executed on the environment. So with workload management, we can pull a lot of more activity out of the resources that you have. Our last topic today is database replication. Database replication is a key feature to enabling the Yellowbrick distributed cloud architecture. What database replication really does is give you the freedom of deployment, whether that's deploying your data in a cloud or on-premise, and how your users are going to interact with it, whether it's on Yellowbrick instances or on a Kubernetes cluster living in a public cloud environment. Replication in Yellowbrick is asynchronous. Once data is committed, we replicate it. So what does Yellowbrick do when it's replicating? How does that actually happen? Well, you can think of it as kind of like a continuous backup of data. Once the data is committed into the environment, that backup is moved to a remote database, and that data is then applied And you can choose the frequency of that data movement, whether that's every 5 seconds or every 5 minutes or 5 hours even. It really protects your data. So in the event of a disaster, you can either fail over or fail back between the two different environments, but knowing that your data is protected. Further, what key feature that replication gives you is it enables deployment freedom. Whether you want to deploy at the edge and move data on a backhaul to an on-premise system or deploy into the cloud, you have the ability to choose where you want your workload to run, and it will all run on the same Yellowbrick experience. So let's look at a couple of these scenarios. Scenario 1, active passive. So what we're doing here is you can have a production workload running in a data center, and that can be replicating to a DR site. Now, again, this is configurable. It could be every 5 seconds, or it could be a longer period of time, depending on what the nature of your network and how often your data is updated. But it's not necessarily that it's just another DR data center. It could be in the Yellowbrick cloud. We have a DR service that you could replicate your on-premise data to the Yellowbrick cloud. Or maybe what you want to do is replicate certain workloads to a cloud so that other users in your organization can interrogate that data from, say, AWS or Power BI running in Azure. Let's look at another scenario. Scenario 2 here is bidirectional active passive. In this scenario, let's say we have a East Coast data center or an East Coast cloud provider and a West Coast data center, and they're each creating data, and they want data protection across these two different environments. Well, in this scenario, you could have a database A, which is sourced and being created on the East Coast, and we can replicate that data across to the West Coast data center, and you can see there's a read-only copy of that data over there. And then we'd have database B, where that data is being created on the West Coast, and it's going to be replicated back to the East Coast. And so here, both sets of data are protected, and in the event of one going down, all your data is able to be accessed. And let's go through this third scenario. So we can look at this one as kind of a distributing workloads, right? So here the idea is we'd have a production hub that's creating data, and then it's pushing that out to multiple different other environments. So the database is read-only when it's replicated out. And let's say you have a scenario where you have a load balancer and you have super high concurrency and you want to make sure that you guarantee an SLA. Well, this enables that. But it's not necessarily that we're just replicating to 3 different physical systems, maybe in a single data center. You could be replicating data to the Yellowbrick cloud, and again, have database as a service offered up to your end users. Or again, let's say you want to pick your infrastructure and you want to deploy on AWS or in Microsoft's cloud or Google's cloud. You have the ability to pick where you want your data to run. So let's recap the topics that we discussed today. We talked about advanced security in Yellowbrick, things like securing the physical hardware or the end user connections to the system. There's also the really unique features like CARE, the column at rest encryption, which allow you to grant or revoke access to keys, which allow users to see encrypted or unencrypted data. There's also advanced workload management, which allows you to get the most out of all the resources in the Yellowbrick system. And then finally, database replication, which really enables the Yellowbrick distributed cloud architecture. You get to decide where do you want your data and how do you want your data to be interacted with, whether that's running on Yellowbrick instances or a Yellowbrick database as a service or Kubernetes stack running in a public cloud or at the edge. Yellowbrick gives you the ultimate flexibility. So that concludes the session on advanced features within Yellowbrick. And now I will begin the next session, data warehousing for distributed clouds. This will include a demo of some exciting new software from Yellowbrick. Today's agenda will be talking about distributed clouds and what that means, the Yellowbrick Manager, and then we'll be doing a demo. So distributed clouds, what is it? So distributed clouds are characterized by the deployment of cloud software and hardware stacks outside of the public cloud provider's data center. You could think of it as a mesh of interconnected cloud resources to form a best-of-breed logical cloud. These stacks enable the ability to run applications developed for the public cloud in a company's own data center and in other locations, such as multi-access edge computing centers connected to 5G cell towers, or on a factory floor to support IoT applications in manufacturing. The distributed cloud offers reduced latency, increased data sovereignty, higher security, addresses data gravity requirements, and provides uniformity in terms of infrastructure and services. Distributed clouds also provide support for cloud applications in remote locations, which may be only intermittently connected to the internet, if at all. So can anyone do this? Well, no, or barely. If you're bound to a public cloud provider, you can't live at the edge or on-premise. Further, if your database is on 30-year-old technology, you're probably not efficient at running at the edge on a limited number of CPUs. Yellowbrick was written from the ground up to be efficient on any platform, on-premise, in public or private clouds, or on optimized instances, or Kubernetes, or even at the edge with limited resources. Yellowbrick Manager provides a uniform control system that uses Kubernetes container orchestration system to enable users to manage and control both cloud and on-premise deployments with enhanced performance capability. So next, let's talk about the demo environment that we have set up. So for the cloud environment, we're going to be running the Yellowbrick Manager software off of a laptop, my laptop, located in Austin, Texas. That laptop is also going to be connected to an instance in AWS US West 2, an instance in San Diego, California, and also an instance in Ashburn, Virginia. So let's get into the demo. So let's log into this environment on my desktop. So let's go to our instances. You can see there's 3 instances here. The one on my laptop, which is local. There's YB62 located in our YB Cloud East. That's in Ashburn, Virginia. And YB92 located in Salt Lake City. Drilling into Salt Lake City, we can see there's 10 databases. We're going to drill in here. There's a database Summit REPL source. As you can see, there's no tables. That's where we're going to create data. Here, YB62, that's the target of the replication. So let's go take a look at how we set that up. Here we create the database, and then we create a replica, and there's a frequency of about 5 seconds. Now let's create a table and put some data into it. There, we've created a table. Now let's insert a couple of rows. That's done. Let's run over here and see that new data, if it's, a second, refreshing, and let's drill in. Now we can see that test replica, and we can see there's 8 rows there. Let's run these other tables real quick, get those created and replicating. That one's 100 million rows, a couple thousand or million in these other tables. So run these. Now let's jump over to 62. So 62, let's get our target database here. And we want that replication target. As you can see, that table is replicated now. And let's drill in here, and we can see the 8 rows that are created here, 1 through 8. Yellowbrick is awesome. Data warehousing for distributed clouds. All right. We've got a couple other tables that we created over there on YB91. We can see those have created. Let's take a look at those tables. So there's Summit, drilling in. We can see there's a couple tables now. So customer 1945, it's got about 42 million rows plus. Date down, not much there. Store returns, though, that's where we did the 100 million rows, okay? And there's also in the background going to be some scripts that are kicking off, but let's see where those tables are on replicating over. So drill in here, let's see if those other tables have gotten copied over yet. Not quite yet, so might be moving across. Remember, we're moving data from Salt Lake to Ashburn, so it takes a minute to get that data across the country. We're also starting streaming inserts. You might see those tables show up here quickly. So there's those first tables that we created. They're all here, 100 million rows. Look, that's like 10 gigs, a couple of seconds or so for it to come on over. Now let's go look at this inserts. All right, here's the inserts table. Let me refresh real quick, make sure the data gets pulled in by the manager. All right, we've got more tables now. This dimension has been streaming data for just a couple minutes, maybe a minute. 536,000 rows. This fact table, we've already streamed in 1.4 million rows. This other fact, let's see where we're at on it. 1.8 million rows have been streaming into this. Now, we're also going to replicate that data, but let's get a count of the idea of how many rows are there right now. So 91, we're going to set to the source. Let's run this query to see how many rows have been inserted into this table. So quite a bit, right? So dimension, about 872,000. Fact, about 2.4 million. So quite a bit of data. Now, let's go see if any of this data has been replicated over. So we're going to jump over to YB62. Let's set our database here. Let's drill in here. We can see all the tables are there. Okay, so let's get a count. And we'll run this. And okay, not that much data, but remember, every 5 seconds it's going to update with more replication. So let's run it again. There you go. Look at that. That's a lot more rows moved over. 1.5 million rows there for that fact table. So let's run it again. In between replications, probably. So you can see how replication enables data warehousing for distributed clouds. We can decide where we want to create data and where we want to consume that data, and replication will automatically move that. This is what distributed cloud data warehousing is all about. All right, for this last part of the presentation, what I'd like to do is show you some things running on my local laptop. So we're going to be dealing with this instance laptop 2. It's running on my laptop. We'll drill in here. So as we can see, this is a 2-node system. There's about 8 gigs total. So you can think of this as like limited resources running at the edge. And what can we do with that? We have 6 different databases. So we've got this Summit database that we're going to be streaming data into. I have a Python process that's already kicked off and has begun streaming data. You can see since the beginning of this conversation, streamed in about 1.1 million rows. So that's pretty good for an edge node, right? Let's go take a look here. Let's see how many rows came in over the last time frames. So I have a query here. We're going to be going against this. Oh, we've got a couple more tables here to look at. So let's take a look at this guy here. Let's see if we can catch him while he's streaming data. All right, so about 70,000 rows in the last minute. Over here we can look and we can see that there's about 1.1 million rows that was streamed in over the last 5-minute time frame. So again, this is what we see edge nodes being used for: streaming data, IoT devices, alerts on manufacturing floors, things of that nature. And so with the resources of this single laptop, we can get quite a bit of work done. So let's update this here. So again, we are streaming data as we're talking and building new rows and new tables. So now there's more tables. We got 6 tables, about 1.6 million rows. Let's do this count here. We'll associate this with laptop 2. Yes, Summit database. And then we're going to run a query here against that fact2 that was kind of a little more quickly generated. So within a minute, about 300,000 rows were streamed in. Let's take a count across all these tables that we've been streaming data into. And again, when we started talking, there was no data in any of these tables and they didn't even exist. So let's see if all these tables, we can get a count of how many rows we're going into each one of these tables. So here we have DIM 1's already at 2.1 million rows, and we've been talking for about 3 minutes here. So that's a lot of data we're getting in here relatively quickly, right? Let's see if we can capture this one again. See if we can see some more real-time streaming that's happening in this environment. Here we go. Wow, that's a lot. So that's 480,000 records in about 5 seconds. So close to 100,000 rows per second. Again, we're doing this on a laptop with a limited number of resources. So you can really see how Yellowbrick can spawn from very small instances to very large instances like we were showing you with the replication. So lots of things we can do here with different instances. So as you can see, Yellowbrick offers breakthrough price and performance for any type of use case. We can do 100x performance improvement over most SQL analytical processes that we encounter. We support thousands of concurrent users, and we do that at any scale. During the demo, you saw a few gigabytes being loaded onto a laptop, but being streamed in at high rates. We also can do the same thing and scale all the way up to multiple petabytes of data. And we could do all of this with about an 80% cost savings to you. So get started with a fast and free test drive. Yellowbrick offers a free 7-day trial. You get to use the Yellowbrick Manager, as you saw me using today. You can run single queries and test your tools against that same database. You can try our bulk loading service, and you can sign up today at yellowbrick.com/test drive. I want to thank you again for joining us for Data Warehousing for Distributed Clouds.
Hello, everyone, and thanks for attending today's session on building a self-service distributed cloud with Yellowbrick and Denodo. My name is Lorenzo Danesi, and I'm a systems engineer at Yellowbrick. I've been in the data warehousing space working with MPP technology for more than 20 years, and I'm really excited to work at Yellowbrick because I truly believe it's a game changer in data warehousing. My role at Yellowbrick involves a few things, including supporting account executives for existing and new business, plus doing proof of concepts. I'm excited to be working with Denodo and having Denodo as a Yellowbrick partner supporting the Yellowbrick distributed cloud. Hi, Santosh. Tell me a little bit about yourself and what you do at Denodo.
Thanks, Lorenzo. My name is Santosh Murthy. I'm a partner channel sales engineer working with our technology and system integrator partners. This is Paige, by the way. She's a Schnauzer Doodle. And well, I've been working in data integration, data management for the last 20 years. I'm excited to join Denodo about 6 months ago with data virtualization really being on the forefront of enabling cloud and hybrid cloud technologies. This has been an exciting time to partner with Yellowbrick on this summit, and I'm excited to be here.
Okay, let's begin and dive into the session. So in today's world, data is growing and becoming more and more diverse, especially when you consider IoT and the data that is constantly being generated. Financial services require more history data to make accurate decisions in real time and stay within legal data retention periods. Telecom now with 5G connectivity can generate massive amounts of data. This is just the tip of the iceberg. There is now a critical need for lightning-fast data analytics solutions that can support initial processing at the edge, real-time streaming data with large volumes of rapidly changing data, and complex interactive analytics in centralized private and/or public cloud environments. Those solutions also need to be flexible to meet any need and complement any IT approach without a massive investment in technology or new skill sets. Current options are too limited for those tasks. For example, NoSQL options like Cassandra and HBase aren't designed for real-time analytics at scale. Cloud-only options like Snowflake have poor and unpredictable price performance and poor latency. And data lakes have proven to be useful only as low-cost data stores. For most companies, those limits make real-time analytics at scale a pipe dream. Yellowbrick Data Warehouse removes the limitations of legacy and cloud-only alternatives. Yellowbrick is the new modern data warehouse designed for new era of analytics. Yellowbrick is built from the ground up to take advantage of highly optimized instances which can query data sets with billions and even trillions of rows with amazing speed. It is designed to take a load and go approach. And what I mean by that is you can load data and start querying without worrying about creating index or statistics. It's done all automatically. Yellowbrick offers the best price performance for real-time workloads available at scale while offering the choice to deploy data warehouses in data centers, private clouds, a SaaS model in public clouds, or both as a hybrid deployment, along with near real-time replication across all those instances. This is the Yellowbrick distributed cloud. And as I said, Yellowbrick delivers the data warehouse for distributed cloud, a product for all people wherever they may happen to be. And here's how Yellowbrick does it. The latest generation of Yellowbrick instance is called Andromeda, which is designed and developed to be self-managing. It's incredibly simple to use compared to other data warehouses. Often customers just allocate a quarter FTE for DBA tasks for Yellowbrick. And things like indexes and statistics gathering and vacuuming aren't required with Yellowbrick. This concept applies to every part of the Yellowbrick's distributed cloud. On the private cloud, it can also be deployed on Kubernetes stacks. And on the private clouds, it can be deployed as a service with private link connections to AWS and Azure, and Google's private connection is coming soon. We also deploy on the public cloud Kubernetes stack, which can also be self-managed or as a SaaS model. And finally, at the edge, where you have the option of the Andromeda instance on laptops, PCs, or specialized edge hardware that support the modern Yellowbrick Andromeda platform. And on the cloud provider's edge infrastructure also, such as AWS wavelengths. And now I'll pass it over to Santosh to talk a little bit about Denodo.
Denodo is essentially the middle layer in between the data consumers, whether you're using a BI tool, a data science tool, or our self-service data catalog, and the data sources. Yellowbrick Data Warehouse is one of the many sources that Denodo supports. We provide an abstraction capability to reduce the complexity of physically moving more data around. We provide a simple abstraction layer so we act and feel just like a database without actually physically storing or moving data. We provide real-time access to the data for the various data consumers so that they get data in real time without having to wait for data to be physically persisted across multiple environments. As part of the data virtualization platform, we provide enterprise-ready capabilities such as data security, column row-based masking, column level security, and we can integrate with your existing entitlement systems. It can be deployed in the cloud, on-premise, or hybrid, which is most commonly being used today.
Thank you, Santosh. The next question is, how do you manage all of this? Well, Yellowbrick Manager will maintain all of the instances within the distributed cloud. You can view the instances and see all of the details, including storage utilization, capacity, and health. You can also view all of the databases within an instance and drill down to the details and easily load Yellowbrick tables from S3 and more. While Yellowbrick Manager helps you manage your instances, Denodo is the umbrella that allows you to combine data from the various instances in the most efficient manner. One important thing to note is that you are as fast as your slowest part. And what I mean by that is you must be aware of the data that you're working with. So moving data across networks can be slow. You want to be mindful if joining data between two or more data sources, how that data will move and how much data will be traveling across the network. For example, you don't want to join a billion rows from one instance to a billion rows to another instance. There are various techniques and features you can take advantage of to maximize the performance, such as filtering data at the source and replication. So that takes us to the demo, where I will demonstrate how Denodo and Yellowbrick work together to combine distributed data in the distributed cloud. Denodo is running on a Windows AWS EC2 instance, which will orchestrate joining the data in the Yellowbrick distributed cloud. Then I will use the Denodo ODBC driver to connect Denodo environment to Power BI to graphically visualize the virtual views in Denodo from Yellowbrick tables that contain billions of rows, all in real time. So this is the Denodo Web Design Studio interface, which I will be using today to create data sources, base views, and derives views. And after I log in and select the Summit virtual view, the first step is to define your data sources. I predefined 3 data sources that are in the Yellowbrick distributed cloud. So the YB Edge is a Yellowbrick Edge instance that contains sales data generated by point-of-sale systems. YB Private is a private cloud instance that contains sensitive customer data. And YB Cloud is a Yellowbrick cloud instance that contains data that is not sensitive, such as US states information. So Denodo's job will be to orchestrate combining the data from these Yellowbrick cloud instances. So the data sources are defined using JDBC. Yellowbrick is supported right out of the box. So you enter the Yellowbrick JDBC connection string, username and password, and you're good to go. And if I switch over to the read and write tab, you can specify the Yellowbrick bulk loader called YB load that can load data at wire speed. YB load can load data into Yellowbrick tables as fast as it can be provided. Denodo will use it when it needs to transfer large volumes of data between instances. The next step is to define the base views, which store only metadata of the Yellowbrick table or view. The data stays where it lives. So I can travel through the tree view here, and I can see the tables and the views that I can choose for my base views. So I've already created one called store sales here. I've defined it, and as you can see all of the column information. I can query the base views via Denodo Virtual Query Language. VQL is very similar to SQL, and it's actually based on Postgres, like Yellowbrick is also. So it's easy to query the base view in the VQL tab. So here I'll just do a count. Just select my virtual database, and I'll just drag the store sales table in here, or view, and I can execute this. And you can see the power or the performance of Yellowbrick coming through here. It scanned the store sales table to return a result set of almost 3 billion rows. And I can also do that with another one of the views. So I'll take a look at the customer view. And that table is in another Yellowbrick instance, and that one contains 12 million rows. So the next step, or the final step, is to combine the data that the base views are pointing to. So I have pre-built a derived view called store sales. So I can double click on this, and you can see all of the columns within this view here. And I can also look at the different columns. And from there, I can also look at a derived view here. So if I look at the derived view, these are the columns that are created from that view. So I have the sum of the sales price, the quantity by month, year, and state. And I can also see through the tree view where that data or how that view is being orchestrated. So the sales view by state does a group by and joins to the sales table and the date table located on the YB edge instance. And the customer information is coming from the YB private instance, and the state's information is coming from the YB cloud. So from there, I can go to the execution panel and I can do a sample of that view. So that returned the combination, or Denodo orchestrated that execution and returned the sum of the sales price and quantity by month, year, and state. Now let's visualize this using Power BI. Denodo Power BI Custom Connector is an ODBC-based connector that can connect to and access the Denodo platform to create dashboards and reports. I have pre-built a report based on the view that we just saw. While I'm bringing that up, I can switch over to the Yellowbrick System Management Console. So the Yellowbrick System Management Console allows you to look at the health of the system and resources. And you can also look at the database and manage them from here. But you can also monitor the current and the past queries. So if I just click on the active queries here, I can see that 17 seconds ago, a query was executed. And I can see that that actually came from the Denodo platform. And this is the SQL that was sent to Yellowbrick. And in summary, I can see that that query scanned almost 3 billion rows of the store sales table. It actually scanned almost 2 million rows of the customer information and 1 million rows of the date dimension table. I can also look at the plan that Yellowbrick puts together to execute that query. And if I look at the statistics, I can see resource utilization and also timings. And I can see that this query took roughly 2 seconds. So if you think about it, it returned a result set in 2 seconds for 3 billion rows. So that's actually sub-second per billion rows. So if I switch back over to the Power BI, you can see that it has plotted the results on the map. And I can hover over the map and see the details of each state. And I can also filter the data by month, name, and year. So if you look at this amount for Washington, the last 3 digits are 287. So I can filter on that year. And I can pick the years that I want to filter on. And if I switch back over to the System Management Console, I can see that query came directly to Yellowbrick, and that took 1.5 seconds here. And this is the query that actually sent the filtering of that query. So, and if I hover back over the Washington, you can see that the value has changed. So you can also look at the results in different graphs, whether it's a pie graph or a bar chart. So that's pretty amazing, the speed that Yellowbrick executes sub-second response time per billion rows. Now, the way that I built this report was through the Get Data feature of Power BI. So if I click on that, I can enter the Denodo ODBC driver. I can select it, enter the DSN name, click direct query so that every click of the mouse sends a SQL statement to the instance. So I'm getting real-time results. And here I connected to the Denodo platform where I can see all of my views that I created. And from here, I can create my report. So that concludes the demo for today. And some of the key takeaways from today's session is that Yellowbrick can be deployed anywhere and can query data sets with billions of rows with amazing speed. No other data warehouse can match Yellowbrick's price performance. And Denodo has the advanced engine that can optimize and orchestrate execution across data sources, including every facet of the Yellowbrick distributed cloud. And that the combination of Yellowbrick and Denodo will help your business be more efficient and accomplish things that you couldn't do before, such as executing ad hoc queries over large volumes of data in distributed and hybrid cloud environments, all in real time. Thank you again for attending, and I hope you enjoyed the session.
That's our event for today. I hope you found it informative and that we provided you with insights on how to plan for the future of distributed clouds in the enterprise and how to get real-time value from your data. If you have any remaining questions, please chat them now. And thanks very much for joining us at Yellowbrick Summit. We hope to see you soon.